Okay. Right. So, shall we start the class? Write the topic work, energy, and power. The work, power, and energy. Kya मतलब ये बोलिए आप? Work, energy, and power. Who work, power, and energy. Those are like three things that we have to discuss. Work, power, and energy. So these are the three topics that we are going to discuss. It's better if we write it as work, energy, and power because we are going to discuss work first, and then we'll be discussing energy, and then we'll be discussing power. So if you ask me about the complexity of the theory, it's not complicated as any of the other lessons that we have in your syllabus. Syllabus it's not complicated at all. Initially, like before the new syllabus, not the new syllabus that I'm talking that implemented in 2017. The syllabus before that, not even that, the syllabus that way behind, right? So in those syllabuses, they have included integration related concepts when it comes to this lesson, right? So now when it comes to applied mathematics, actually the our applied mathematics syllabus, the syllabus that you are studying right now, is very simplified. Very simplified. Again, compared to the things that you study, that you have to solve, compared to the questions that you have to solve below 2000. Okay. Year 2000 and we never compared to that one. The lesson complexity is very much reduced, especially when it comes to this lesson. Most of the concepts has been simplified, and the amount of theory that you discuss in physics level and A level some concepts are more simpler than the physics concept that you study in A level physics. So when it comes to work, energy, and power. So the calculation, when it comes to the calculations, the learning outcome that they expect from work, energy, and power is somewhat little one step ahead than the physics MCQs that you can get from work, energy, and power. So other than that, the complication of the lesson is like uh, compared to the other lessons, 1% it's not complicated at all, right? Okay. Right, the main topic work, energy, and power. We have to discuss a very few theory parts. Like if you take my notes, usually when it comes to the theory classes, I give you a lot of notes when it comes to applied mathematics, right? Applied mathematics, good up notes, take the equilibrium of system of coplanar forces and continuation of that. So we have taken a lot of notes, right? But when it comes to this one, for all the three topics, the maximum notes that we are going to take is like for about 3 or 4 full scale papers, right? 6 pages for the mind, right? So write the subtopic work, okay, and put a star mark and write. Write the subtopic work and put a star mark and write. Write the subtopic work and put a star mark and write. Put the subtopic work and put a star mark and write. Don't write in red color, just write a normal note. It's not that complicated to understand. Okay. Put the subtopic work and put a star mark and write. So am I glitching? No, right? Right, my video will lag when online students to message in the chat box. Is my video lagging? No, right? Okay, great. Because I'm recording in OBS also in my device. My device is stuck. Okay. So in the chat box, I sent you the new. Okay, no? Right. So add the subtopic work and put the star mark and write. Put the star mark and write. The work done by a constant power. The work done by a constant power. The work done by a constant power. The work done by a constant power is given by. The work done by a constant power is given by. The work done by a constant power given by the magnitude of the force given by the product of 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 the magnitude of the force applied to the object the work done by a constant force is given by the product of the product of the magnitude of the force applied to the object and 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 the component of the displacement component of the magnitude of the component of the displacement. That's the correct definition. The magnitude of the component of the displacement in the direction of the force. The direction of the force. What's the definition of a work? The work done by a constant force is given by the product of the magnitude of the force applied onto the object and the component of the component of the magnitude of the displacement applied to the magnitude of the displacement in the direction of the force. In the direction of the force. Once again, the work done by a constant force is given by the product of the magnitude applied onto the magnitude of the force applied onto the object and the magnitude of the component or as magnitude of the magnitude of the component of the displacement in the direction of the force. Component of the displacement in the direction of the force. Once again, if you did not write the definition properly, I am gonna the work done by a constant force is given by the product of the magnitude of the force applied onto the object and the magnitude of the component of the displacement in the direction of the force. In the direction of the force. Alright. Again, let's say here we have a point. So this is the point where we are going to move, which we are going to move. Okay, this is the point which we are going to move. I take the point as capital A. And in this direction, I apply a force, capital F. Okay, capital F. And to this direction, at a theta angle, okay, the object makes a capital is displacement to capital B. Right, at a theta angle, this point, this object, let's say capital P particle, this capital P particle makes a displacement from A to B in this direction. So the work, okay, let work be capital W. the notation that I am using throughout the discussion for the work to denote the work is capital W. So like in physics, we denote D represents the distance, and X represents the displacement, V represents the velocity, T represents the time. So we use notations in physics, right? Same as that, to build up our discussion in the future calculations also, I will use the notation for the work as capital W. So remember, this is the notation that I'm using for the work as capital W. But that doesn't mean this is the SI unit watts. Because in future discussions, in another few minutes, we'll be discussing about energy. After discussing about energy, we'll be discussing about the power. Okay, when we discuss about the power, okay, that's the rate of change of energy or rate of change of work. And ඒකට තමයි අපි power කියලා කියන්නේ. So the its measuring unit is going to be watts. So watt එකත් capital W only. So at that time, don't get confused. That's a unit of measurement. Now this one is just a notation to develop the formula. So the work done by this capital F force is given by the magnitude of the force. මෙතන දාන්නේ size එක විතරයි. The magnitude of the force and the component magnitude of the component of the displacement. Magnitude of the component of the displacement, not the direction එකක් නෙමෙයි මෙතන consider කරන්න. Magnitude of the component of the displacement in the direction of the force. Magnitude of the component of the displacement. Magnitude of the component of the displacement in the direction of the force. Okay, the force. This is the component. So this is the displacement. That's component in the direction of the force is this. What is it? S cos theta. S cos theta. S cos theta. Work is given by force applied onto the object multiplied by displacement component in the direction of the force. Okay, this is the force, magnitude of the force multiplied by the component of the displacement in the direction of force. In the direction of force. In the direction of force. But actually we are considering what? The magnitude of the magnitudes size. So since we are considering the magnitudes only, since we are considering only the magnitudes and we are taking the product of two magnitudes, this work is a scalar quantity. It's a scalar quantity, not a vector quantity. It's a scalar quantity. Okay, it's a scalar quantity. So this is the formula that we calculate the force. This is a formula that we calculate the force. For an example, let's say there's an object like this kept on a smooth floor, and to this object I apply a capital F force, and it's on capital A point. It's at capital A point, and I'm moving to the capital B point. Okay, or no? The displacement is simple x. Okay, displacement is simple x. So if I want to calculate the work, so I'm going to take the work as W. The work is given by the force applied onto the object, magnitude of the force. Magnitude of the force applied onto the object multiplied by the component magnitude of the component of the displacement in the direction of the force. So now the thing is, the displacement happened this way. So if I put S cos theta, X cos theta is going to be cos 0. Cos 0 is 1, same as x. Now, the work done by this force from A to B is Fx. Let's take another example. There's a ball capital B at point capital A. So I apply a force 10 Newton here. And the ball makes a displacement to the point capital B. To the point capital B. 10 meters at a 60 degrees to the horizontal. What's the work done by the force? What's the work done by the force? Is given by the force's magnitude multiplied by the magnitude of the component of the displacement in the direction of the force. The direction of the force. Force direction negative. Force is applied here in this direction. What's the displacement made by the object? Which means they are asking about this. They are talking about this displacement. So 10 meters, if I bend the vector on the side of the angle, if I bend the vector, if I fold the vector to the side of the angle, it's going to be cos theta. No? So 10 meters cos 60. So it's going to be 10 meters cos 60. Cos 60. So this is going to be 10 multiplied by 10 times cos 60 is half. 5. So it's going to give you 50. This one is given in newtons. This one is given in meters. Newtons. What's the SI unit that we write the force? Newton. SI unit again Newton. kg m square s minus 2. No? So kg m is minus 2, right? Mass times acceleration. kg m is minus 2. Mass times acceleration. Times m. So this gives you kg m squared s to the power minus 2 or s minus 2. This is what we call joule. Unit is J. Unit is capital J. So the unit of measurement for work is joule, given by capital G. Given by capital G. That's only for the work. Work eකට concept the topic work is done. What you have to remember, the work given by the force applied onto the object multiplied by the component of the displacement in the direction of the force. Right? That's the idea of work. The work is on a idea I gave you the note. Quickly write these examples. Write this one. Do those 2 examples. Write this one. Quickly take this note. You are finish it off. Voice is bit lagging. Is that so? Am I not audible to you properly? Quickly remember message in chat box, guys. Lagging ne mang himing kata kare. Quickly remember message. All good, no? Right. So now confirm me through chat box. All good, understood. I need individual responses. All good, understood. I need individual responses. Quickly. Clear, 100%. No confusions. Right. Sometimes you might see some books, some reference books, or sometimes maybe in schools, they give you the formula for work as F cos theta times S scalar theta. This gives you the answer, okay? Maker gives you the answer. Because when the work is a scalar quantity. When it comes to scalar quantity, because we consider magnitudes, magnitudes, we consider scalar quantity. We consider magnitudes. We are not considering the vector properties. So, the cross multiplication F multiplied by S multiplied by cos theta. The cross multiplication of scalars, we can change the order. Here, 1 multiplied by 2 multiplied by 3 may come only 3 times 2 times 1, no problem. In case, let's say in some other parallel universe, work is a vector quantity. We consider work as a vector. Then by the definition, if we take, okay, by the definition, if we take, then make it right? Just an idea, just an idea. Let's say we are taking the dot product instead of the cross product. Since there is a scalar quantity, we can put the cross product in. Let's say we are taking the dot product. What happens? Then F dot S cos theta නම් ගන්නේ. We cannot write as S dot F cos theta. මේකයි දෙකක්. මං කිව්වා හරියද? නෑ බා වැරදි dot product එකේ එහෙම අවුලක් නෑ. Why? If you can remember, A dot B is equals to B dot A කියලා ලිව්වා. මං ඒ වැරදිද කිව්වේ. I know that you are not going to question me. වැරදි එක කියලා හරි එක කිව්වොත් තමයි මට මතක ඉන්නේ. දන්නේ නැතුව වැරද්දුවේ නෑ හරි. ඕනකමෙන් වැරදි. But when it comes to cross product, එහෙම කරන්නේ. හරි. දැන් මතක තියාගන්න. Here we consider scalars. Actually, force is a vector, S cos theta. This is a vector. By multiplying two vectors, we get what? A scale. So, මෙතන multiplication එක දැම්මට හරි. This is a scalar quantity, okay? So, is this a vector dot product? Is this a cross product? This is a scale. We are considering the magnitude of the first. We are considering magnitude of the this one. What is it? Component of the displacement in the direction of the wave. Right? So this gives you the answer. Because because those are scalar. The work is a scalar part. Because it still gives you the answer. But by the definition, if you take the definition of work is this. Magnitude of the force multiplied by the magnitude of the displacement in the direction of the force. Magnitude of the displacement in the direction of the force. Right? This one gives you the answer. හැබැයි මේකේ ගණන් හදන්න try කරන්න එපා. Try to do the calculations using this. Right. Done. Write these two examples. It was the subtopic. Conservative forces. Write the subtopic. conservative forces. Write the subtopic, conservative forces. Write the subtopic, conservative forces. In Sinhala we say that Samskritika Bala. Why I am giving you these Sinhala terms? The English medium ගත්තොත් past papers with the markings you can find I think until 2000 suppose. But if you take Sinhala medium past papers 1986 වගේ වෙන එකක් past papers වලට හොයාගන්න පුළුවන් with the markings. So when we are doing those past papers, now for this lesson I included questions until 1989, but after that I removed all those questions. I included until 1999. Because duplicate questions that may, because the other questions are like very complicated for the level of understanding that you get from the current syllabus. So I but those practices you will get it in your papers. I mean, the alien papers, right? Since we have done work energy power today, so actually I was initially planning to do work frameworks today. That was my original idea. And the mistakenly in the initial post I put work energy and power today and frameworks for the next week. So it was a main date. Right. Write the subtopic. Under work is one subtopic. Before we go to the energy part, we'll discuss about another part. What is it? Conservative forces. Conservative forces. Right. Write the definition. Write the definition of conservative forces. Write the definition of conservative forces. Conservative forces. Right, write like this, write the definition. Write the definition. Write the definition. The force acting on an object. The force acting on an object. The force that is 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 acting on an object. Which is in a gravitational field. The force acting on an object which is in a gravitational field. The force acting in an object on an object which is in a gravitational field is a constant is a constant irrespective of the placement irrespective of the placement of the object irrespective of the placement of the object within the same gravitational field put a comma such force is referred to as a conservative force. Such force is referred to as a conservative force. If there is an object inside a gravitational field and if there is a force acting on that object, and if that force is not changing its value when I take that object from this position to this position within the same gravitational field. If the force is not changing and same value for the force, same value for the force, such force is referred to as what? a conservative force. The force acting in an object which is in a gravitational field is a constant irrespective of the placement of the object in the same gravitational field. Then such force is referred to as the conservative force. Right? So let's say this is the gravitational field. A gravitational field. When the gravitational field is actually there's an object here. So on this, the weight is acting. Okay, weight take a force, right? An imbalance force for this, an external force for the object. So I'm placing this object in the method, right? I'm placing this object here. Same weight. I'm placing this object here. Same weight. I'm placing that object here. Same weight. Weight is not changing. Weight in the sense the force is not changing. The gravitational force is not changing. So gravitational force is a conservative force. One of the prime examples that we can give. So example එකක් ගන්න පුළුවන්. Examples we can say gravitational force. Gravitational force, which is the weight of an object. What else? තමුණක් කියන්න පුළුවන්. Conservative forces. What else you can say? What else you can say? Gravitational force within a gravitational field. If I'm considering a gravitational field. So I specified the conservative force definition to gravitational field. That doesn't mean a gravitational field එකටම විතරක් වැඩ කරනවා කියලා නෑ. If it is an electrostatic field, okay, within the electrostatic field, okay, if within the electrostatic field, if we keep an object, right, the intensity, the electric intensity, විද්‍යුත් තීව්‍රතාව, right, that force is a constant in the electrostatic field. So I specified this one. Since we are dealing with in A-level mathematics, especially in applied mathematics, we discuss about gravitational field things. In physics only, we are discussing the gravitational fields, magnetic fields, and the electrostatic field. So where fields can kata karang in physics. I think still you haven't started gravitational fields or electrostatic fields. Patan karang into it, right? In physics. But if any of you all can do the fields part, පොඩි self study එකක් කරලා හරි fields part එක ඉවර කරගන්න පුළුවන් නම් it's way better because fields part එකේ කැලි තුනක් වෙනවනේ පුතා. Gravitational, electrostatic and magnetic. Gravitational field is a very small part, හරිම lazy. Magnetic field එක, electrostatic field එක ද පොඩ ලොකු. Those are big lessons. To be honest, most of the physics classes, irrespective of who's the lecturer, most of the physics classes, third lesson. Some physics classes are not maths lessons syllabus significant amount of the work in syllabus is done. පුතා ඔයාලට lessons 11ක් තියෙනවා syllabus. या कोबरता lessons 8ක් තියෙනවා. මාස 8යි තියෙන exam. You have 8 lessons to complete. You have 8 months only for the exam. මම අදද මේක කියන්නේ for 2026 batch. Is this the day today that I am telling for 2026 batch about this thing? There are some messages in the chat box. Started gravitational fields. Good. At least one class. right? So I will give you some other examples also for this, right? So that's the definition for it. So for a take example, one of the examples right down here after not repeat. Alright. So what I was saying, physics is very crucial. Antimahari karla ho budadanda maori, right? So the electronics lesson සමහරවම කෙලව ගන්නවා මේක අන්තිම හරිය අර හදිස්සියට කරන්න electronics. I can't remember the lesson number, some lesson number 8 or the 8 or 9 or something. I can't remember. 10th lesson is mechanical properties of matter, right? 11th lesson matter and radiation. Calculations තමයි ගොඩක් තියෙන්නේ theory wise very simple theories. Mechanical properties of matter හරිම easy understand කරන්න. Three properties you are going to discuss. Viscosity and ඔය වගේ මොකක් හරි තුනක් තියෙන්නේ. Viscosity, elasticity and තව something. පට lazy. ඔය ඉවර කරලා දාන්න. Because after oscillation and waves, the next lesson. Thermophysics. I mean, තාප භෞතිකය කියන බලන්න. Thermophysics. Another big lesson. 2 months වගේ ගන්නවා physics වලට ගාන. Right, අල්ලන්න ඉන්න වෙලා නැහැ බං. At least do the maths within the class time itself and finish it. Don't keep backlogs. Recording පස්සේ දුවන්න එපා චූටි හරක් පටව වගේ. තේරුම් ගන්න බලන්න මාසාරයි ඉතින්. So I have 8 months only. Maths syllabus එකේ the part you should do done. Right, syllabus කාව වෙනවා කොහොමද විභාගයට මාසාර කරන්නේ. තුනකට කරන්නේ. Right. Your syllabus February, March, January, Feb second week වගේ pure syllabus එක 99% හරි ඉවර කරලා දාන්න. If it is remaining complex numbers වල චූටි ගාලක් ඉතුරු වෙයි in the sense like Feb second week. By that time sometimes I might be relative motion fully ඉවර වෙලා sometimes circular motion ඉවර කරලා ඉන්නවා. Right. So what about the center of gravity, simple harmonic motion, statistics next month, statistics එකක් ඉවරද? Right. Well, syllabus here. So do the paper class work properly. Live paper class join method. All theory students please join the live paper class. There are set of students who join only for the recordings. So set එකටම call කරලා කතා කරනවා. I called all those recording students and I asked them questions. නිකන් අම්මා තාත්තලා ස්ටඩි විතරක් මෙතන පිස්සු නරන එක දැන්. මාසාටයි. Those who are doing chemistry, inorganic, ඉවර වෙන කාලේ හරියට මම හිතන්නේ. Inorganic, organic ඉවර වෙලා some most of the tuition classes in chemistry they are doing like mathematics only. Industrial chemistry or පිටිපස්සේ lessons ඉවරයි. කලින් හරියට those are theoretical lessons. So physics classes will take a more because the subject is like that. But you should be wise. We can't blame the lecturer because that's not the syllabus is made. Lecturers don't mind the way. The one thing that lecturer could do is මේ මහන්සිය බලන්න නැතුව they could put mail වගේ seminars දාගෙන මොකක් කරලා දෙන්නේ. මම ඒක ඉතර අමතරමක් දාගෙන කරන්නේ. Have to follow the syllabus one. Because I know the last one covered of the syllabus won't help the student. The ගුරුවරයා කරන්නේ නැත්නම් ගුරුවරයාට කියන ගුරුවරයා කරන්නේ. මොකක්ද? දාගෙන කරගන්න. You have to do it. Yes. Chemistry, maths, physics ඉඳන් result එක බලන්න අපහාරයි. engineering කම්ප්ලීට් කරන්න. අපරාධයි. Right. Below that, conservative forces, right? Another definition for conservative forces. Another definition for conservative forces, right? Another definition for conservative forces. Another definition for conservative forces. Write the first star point. Write the first star point. Write the first star point. If the work done by a force, if the work done by a force, if the work done by a force is a constant, is a constant, is a constant, if the work done by the force is a constant, when moving an object from one point to another point, or one place to another place, one place to another place, the work done by a force is a constant when moving an object from one place to another place. When moving an object from one place to another place, when moving an object from one place to another place, moving an object from one place to another place, irrespective of the path, irrespective of the path, irrespective of the path. What a පාරෙන් අරන් ගියත් ප්‍රශ්නයක් නැහැ. Irrespective of the path, irrespective of the path. Then the force is considered as conservative force. Then the force is considered as a conservative force. Then the force is considered as a conservative force. Separately write, separately write, separately write. The work done by a conservative force separately in a new star mark the work done by a conservative force, the work done by a conservative force, the work done by a conservative force is independent from the path we move the object. Is independent of the path we move the object or transport the object. Right. Right. Below that, write an example. Below that, write an example. Below that, write an example. Okay. Write an example. Example කියලා ලියන්න. The diagram shows two paths. The diagram shows the diagram shows two paths. The diagram shows two paths that we can move the object from the point capital A, that we can move an object from point capital A to a point capital B, point capital A to a point capital B, which is straightly below, which is h distance straightly below the level of capital A, which is simple h distance straightly below straightly below the point capital A. Below the point capital A. Point capital A. Point capital A. Full stop and right. Imagine the situation. Imagine the situation. Imagine the situation or the scenario. Imagine the scenario. Imagine the scenario. Imagine the scenario. Is described. Imagine the scenario is described on a vertical plane. Imagine scenario described in a vertical plane. It can make in the gravitational field. Okay, so I'm discussing about a gravitational field at Kathir. Okay, so there's an object. I'll take the object name as capital P. This is the diagram. Okay, now you can draw with me. This is the point capital A. At point capital A, there's an object. At the point capital A, there's an object. So I'm going to take this is the level that I consider. This is the level of A. Straightly below the level of A. Straightly below the level of A. Straightly below the level of A. At a simple h distance. At a simple h distance. At point capital B. At point capital. At point capital B. At point capital B. This is the next position. I have to move the object from here to here. They have given two paths. One path is straightly this A to B. The other path is going from A to C and C to B. Or no? Going from A to B and C to B. Let's take this angle as alpha. This point as capital D. Okay. And this alpha will take this angle as theta. Since it is in a gravitational field and only the force that I'm considering here, okay, only the force that I'm considering here is the weight, mg. The weight of this one. I'll take the weight as mg. So we're going to check whether this mg is a conservative force or not. If it is a conservative force, what should happen? It doesn't matter whether I'm directly taking from A to B, the work done by this mg to take this displacement h, same amount of work should be done by if I'm taking the object from A to C and C to B. When the method A to C work plus B to C work, the total work should be the same work as A to B. Basically, when I'm finally taking the object from the point A to point B, the work done by the object, the work done by the force should be equal to the work done by the same force from the other path A to C and C to B. Okay, so calculate current. Right, first of all, draw this one quickly. Quickly draw that one. right? So I will consider AB part. If you consider the AB part, I will use notations to write this just to give you an idea. Work done in the direction of AB path. Okay, the work done in the direction of AB path. What is it to come? What's the work? Force multiplied by the displacement in the direction of the force. Force is mg. The displacement in the direction of the force is h. So force multiplied by the displacement component in the direction of the force, no? Displacement component එක same h no force එකේ පැත්තට බලන්න h නේද? h. So basically mgh. I did it as one. If I consider the work done by the force mg when I'm taking through AC direction. Let's say work AC. What's the idea? What's the idea? Force multiplied by the component of the displacement in the direction of the force. Our displacement is AC. In the direction of the force, AC cos alpha. Displacement is AC. But in the direction of force, if I am taking AC cos alpha. This is AC cos alpha, which is in our diagram AD now. So I can write WAC is equals to mg times AD. I take it as 2. Now I'm taking from C to B. C to B. Right? So then work from C to B is equals to from the same force. From here to here taking. From the same force, right? mg kemmane. Right? mg කියන force එකෙන්මයි අරන් යන්නේ. mg times cv cos theta. cv cos theta. Why cv cos theta? Displacement is cv. The direction of the force, in the direction of the force, the displacement is cv cos theta. And cv cos theta is dv. In our diagram, it's dv. Then WCB is equals to mg times dv. It's my third equation. Now I can say, finally, if I am moving the object from A to B through the second path, which is A to C and then C to B. A to B will total work is going to be 1 plus 2. What is it? WAC 1 plus 2, right? 2 plus 3. WAC plus WCB. This is equals to MGAD plus MGDB. Take MG outside. So you will get MG AD plus DB. What is AD plus DB? AD plus DB is H. This is H. Therefore, WAC plus WCB is equals to WAB. මොන පැත්තෙන් ආවත් තීරමක් නැහැ. Work is a constant. Work is a constant. The work done by a what? The work done by a conservative force is a constant irrespective of the path. Directly A to B A to C, C to B තව කොයි හරි වටේ ගහලා same work that we have to put in order to bring the object from one point to one point within the same field. If it is done, if the work is done by a conservative force. If it is a different force, conservative force එකක් නෙවෙයි නම් work changes. Right? So this is the idea. Quickly do the calculation, finish it. and then write the subtopic energy. ඊට පස්සේ ලියන්න subtopic energy. Finish this and write the subtopic energy. Done. Done. Shall I erase the book? Volume එකකට. Shall I erase the book? Huh? Okay. Right. And now, yeah. Energy. Right. Below that, put a star mark and write. Below that, put a star mark and write. Put a star mark and write. The ability to do the work. 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 The ability to do the work is referred to as the energy. The ability to do the work is referred to as the energy. Referred to as the energy. In the same star point, continuously write it. That's continuously write. Same point again, continuously write. To do a work, or to perform a work, it requires energy. 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 Once the work is done, 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 the energy transform from one form to energy transforms from one form to another form. Once the work is done, the energy transform from one form to another. Energy transform from one form to another form. Energy transform from one form to another form. Separately write. Put a star mark and write. Energy is a scalar quantity. 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 Below that, right? Unit is kg m squared s minus 2, which is joule. Energy එක මනින්නේ joule වලින්. එහෙම නැත්නම් කෙලිම ලියා ගන්න joule කියලා ලියා ගන්න. Joule. Joule. J විතර ලියා ගන්න. Joule. Right. Put another star mark, right? another stammer. Actually, because make it in a points, explain karana there maybe. Right, work energy power, the points are not something like read the first point value to do the ability to do the work referred to as energy. What the hell I have to explain it then? The ability to do the work is called as energy. Right? If I want to move this object from this point to this point, I am spending my energy. Right? So if we keep here, let's say this is the gravitational potential energy is 0 level. Right? So this one's weight is, the weight is mg. Right? So this is simple h height. Simple h height. Right? So the work it should do from work it should do to come from this point to this point. මෙතනට එන්න මේ object එක කරන්න ඕන work එක. So let's say from this here, the pen is at this point. My marker pen is here, right? And the weight is mg, and it's at the this is the level where the gravitational potential energy is 0, right? This is the ground. Okay, this is the ground level, right? So from here, this is the height, simple h. So if I want to break this marker point from this point to this point, the work that I have to do in order to bring the marker pen from this point to this point is what? How to calculate the work? Force multiplied by the displacement in the direction of the force, mgh. This is what we call the potential energy. Right? Again, the work that I should do in order to bring the marker pen from this h height to this point is mgh. Potential energy. Once I release the marker from here, due to the gravity, this mg doesn't change. Due to the gravity, what happens? Due to the gravity, due to this weight, with the help of this force, it comes down. When it is coming down, what happens? The energy is wasting, not wasting. Energy is spending. Energy is transforming. Energy is consumed. It explains it's a stored energy. Stored energy. Now the work that we should do in order to get the marker frame from this point to this point is called the energy. Like work energy. Right? Is the energy. So when we bring the marker slowly near this one, the energy is spending, energy is consumed. When the energy is consumed, according to the definition, we are doing the work. No, what is the work? Work the object is moved. Right? Object is a movement. Now, for an example, on an object, you apply a force like this. So this is the point of action. Right? Point of action. So actually the originally this one actually needs to be discussed in the physics subject. But come on now, so I'm applying the force like this. I'm applying the force like this. This is the point of action. This is the point of action. Okay. This is the point which the force helps to move this object. And unfortunately, the object is not moving. Not moving means it's not no energy wasted. No work done. No energy spent, no work done. Object is movement. If the object is moving, if it makes a displacement then we say energy spent, work is done. Energy spent, work is done. Move object. No, the point of action. The force's ultimate goal is to move the point of action. But the point of action is inside the object, so object movement. This point of action, what we call in physics as Upayogita Lakshya, Sinhala. Why I am giving you the Sinhala terms again? For the Sinhala terms, it's very much important if you are finding good questions in A-levels. හොඳ ප්‍රශ්න හොයා ගන්නවා නම් සිංහල මීඩියම් තියෙනවා පුතා ලස්සන ප්‍රශ්න. ඉංග්‍රීසි මීඩියම් නැතුව නෙවෙයි. English medium there are very good questions, but it's really hard to find. It's really hard to find. All my tunes or all the questions that you see in my ATM papers, 90% of the questions are from good resources that are referred from Sinhala medium. හොඳ ප්‍රශ්න තියෙනවා. Right. So that doesn't mean English medium don't we have good books? We have lots of resources when it comes to English medium. But unfortunately, none of them are within the syllabus frame in Sri Lanka. Current A-level frame එකේ both හරියද. It's very few. Not there are books, but very few. So I refer to one of the books recently, one of the famous authors in Sri Lanka. Most of the students also refer to that book. Work definition වැරදි. Okay. Work's definition is wrong. The definition of work is what? Definition of work is the work done by a constant force is the product of the magnitude of the force applied onto the object and the magnitude of the component of the displacement in the direction of the object. But the definition given in the book is the work done by a constant force is given by the magnitude of the force in the displacement's direction multiplied by the magnitude of the displacement. According to that definition, the formula is F cos theta times S. Answer you will get the answer. But the correct physics application right? So in those kind of simple things are there. Now, when it comes to simple harmonic motion, the definition of simple harmonic motion goes with the displacement, not the distance. Displacement. If someone is doing the calculations correctly, but still saying the word distance instead of the displacement, it's physics marala. Okay. So that's the thing. So the mic volume has been decreased. How is the audio now? I think mic went off suddenly. More connect වෙලා නෑනේ. Fine. Am I audible to you now clearly? Okay. Right. Now, then here, this is spins energy. මොකක්ද වෙන්නේ? According to the definition, once the work is done, what's the work? Bringing the marker from here to here. Once the work is done, the energy transforms to another form. What happens? Starts with velocity 0, velocity increased. The energy transforms from potential energy to the kinetic energy. Potential energy කියනලා kinetic energy එකට මාරු වෙනවා. Right? Once it hits the ground, we'll discuss about that one in impulse and collision. Impulse and momentum. Collision එකක් වෙන්න කලින් momentum එකක් තියෙනවා. Impulse lesson එක කතා කරමු. Right? Sometimes if the flow is super smooth, mark එක වැදිලා ආයෙ උඩට යනවා. Right? It's infinitely, as a loop, it will happen if the, for an example, බෝලයක් දානවා. Right? So mgh is the force that we have at the moment. No any other forces. It spends its energy and comes here, work is done, energy is transformed from potential to what? Kinetic. ඇවිල්ලා වදිනවා v වලින්. Now what happens? Energy is not energy is not transformed to anything. Not as the sound, not as this one, what is called heat. Energy is not transformed due to the friction, due to air resistance. Nothing happening. Purely mgh transformed to half mv square, or else kinetic energy. And the flow is also super smooth, no friction. Right? So what happens? Move ඇදිලා from the v velocity, again it goes up, I උඩට 0 වෙනවා. ආය පල්ලෙහාට, ආය උඩට. Infinitely ඔය loop එක යයි. If there is no air resistance, if there is no friction here, right? There is no any energy transformation or energy harm is happening at this point. This will happen in infinitely many loops. Hari, interesting, physics lesson ටිකන ගත්තොත්. This is not maths, that is physics. And in past lesson we'll discuss about those parts a little bit. So what's the idea? What's the idea? In order, the ability to do the work is called the energy. When the work is done, energy is transformed from one form to another form. Sometimes potential energy to the kinetic energy. Sometimes from light to the heat. Right? So those kind of transformations. What do we study in applied mathematics? Potential energy and kinetic energy, only basically the mechanical energies. Mechanical energies, potential energy and kinetic energy. Right? So I gave you that one, no? Right. Put a star mark and write. Put a star mark and write. There are different forms of energy that we can discuss. Put a star mark and write. There are different, don't write this picture, okay? I didn't ask you to draw this picture, okay? Just don't draw this. Put a star mark and write. There are different forms of energy that we can study. There are different forms of energy that we can study. But in this section, we discuss only about, but in this section we discuss only about the potential energy and the kinetic energy. Only about the potential energy and the kinetic energy. Put another star mark and write. Generally, these two types of energies, referred to as mechanical energies. Write the subtopic potential energy. Vibhava Shakti. Potential energy. Potential energy. පොඩි note එකක් තමයි ගන්න තියෙන්නේ හරි. So we have potential energy, kinetic energy, and then the relation between the potential mechanical energy and the work. Okay, relation between the mechanical energy and the work. ඊට පස්සේ law of conservation of mechanical energy. ඊට පස්සේ one more small subtopic. What is it? Power. Power එක යටතේ we are discussing another type of force which is specifically for the vehicle types, right? ඒකත් එක්ක theory ඉවරයි. තව 30 minutes වලින් වගේ theory ඉවරයි. Right? Vibhava Shaktiya, right? Which is the potential energy. Below that, put a star mark and write. Below that, put a star mark and write. Put a star mark and write. The energy stored in an object. The energy stored in an object the energy stored in an object due to the placement of the object due to the placement of the object in the gravitational field, because we discuss about gravitational fields only here. අපි කතා කරන්නේ gravitational field එක ගැන විතරයි. That's why I'm specifying the note to gravitational field. Electric fields, magnetic fields, ඔය මගුල් මෙතනට අදින්න එපා. When it comes to physics, you will be discussing about different potential energies with respect to those special fields. හරි දැන් මෙතන මම specify කරන gravitational fields not because I don't know about any other fields or anything. මම specify කරන්නේ because in mathematics we are discussing about gravitational fields only, right? So the energy stored in an object due to the placement of the object in a gravitational field is referred to as potential energy. 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 Right. Now write another star mark. Put another star mark. Put another star point and write. Put another star point and write. Put another star point and write. The energy gained by an object, the energy gained by an object, the energy gained by an object due to the placement against the gravitational force. Due to the placement against the gravitational force. Due to the placement against the gravitational force is referred to as gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Right. Separately write, not a star point, just separately write. Imagine there's an object at simple h height Imagine there is an object at simple h height. Imagine there's a object at simple h height. There's an object at simple h height from a level that is considered as imagine there's an object at simple h height from a level that is considered as potential energy zero level. Potential energy zero level. Potential energy zero level. Put a comma and draw this with me. So this is the level that I consider the potential energy is zero. Basically the ground level, polawa mattama on earth. From that level, okay, there's at a simple h height. At a simple h height, there's an object. At a simple h height, there's an object. And the same object is placed, this is the first instant. There's another instant that we can discuss. The object is simple h deep, okay, from the potential energy zero level. Simple h deep from the potential energy zero level. So this is one single line, okay. Then make a tani line right. Now below that put a star mark and write. 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 Star mark at the PE P dot E potential energy equals to 0 kilo, okay. Right. Put a star mark and write. Make a weight mg. Put the weight mg. Put a star mark and now write. That's until the object of weight mg. The object of weight mg. The object of weight mg. Put a comma. When it reaches to the level, when it reaches to the potential energy zero level, the object of weight mg, put a comma, when it reaches potential energy zero level, 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 the force mg, the force mg, the force mg, the force mg, force mg, do a work, force mg do a work, or does a work, grammar ඔයාලා කලපලා ලියන්න, force mg do a work, or does a work, equal to mgh, equal to mgh, do a work equal to mgh, equal to mgh. What is that? Mg is the force multiplied by the displacement in the direction of magnitude of the displacement in the direction of the force mgh, no? So make work. So I directly gave you that mgh. When the object of weight the object of weight mg, when it reaches to the potential energy zero level, the work done by the force mg do a work equal to mgh, equal to mgh, mgh, full stop. Therefore, when the object is simple h height, the object is at simple h height. Therefore, when the object is at simple h height, from the potential energy zero level, from the potential energy zero level, therefore, when the object is at simple h height from the potential energy zero level, from the potential energy zero level, potential energy zero level, we say that in number one situation, in this number one instant, we say that in number one instant, the object has stored or object has gained, the object has stored or object has gained a potential energy equal to mgh, equal to mgh. At this instant, we say that it's a positive potential energy. At this instant, we say that it's a positive potential energy. We say that it's a positive potential energy. It's a positive potential energy. It's a positive potential energy. Harane. Right. Okay. Then put a second star point. When the object is placed simple h deep or a simple h below, for the second star point, when the object is placed simple h height or a simple h distant or simple h deep, කැමති විදිහක ලියා ගන්න, same idea. Simple h deep below the potential energy zero level. Inside the bracket, right? As in 2. Inside the brackets, right? As in 2. Close the brackets. We say that the object has stored a negative potential energy equal to, the object has stored a negative potential energy equal to, object has stored a negative potential energy equal to mgh. a negative potential energy equal to mgh. මොකක්ද ඒ කිව්වේ? Now listen. Then පුතා, once again, the idea, this is the potential energy zero level. මෙතන potential energy එකක් නැහැ. Okay. There's an object placed at a simple h height. Now stop working and listen. There's an object placed at a simple h height. The weight of the object is simple mg. හරිද? Simple mg. Now, this object, if I want to bring that object to this level, more මෙතනට ගේන්න ඕන නම්, what's the work we should do? Work if I want to get the object from A to B. A in the B වලට. If I want to bring the object from A to B, what's the work we should do? How to calculate the work? The force applied on the object multiplied by the displacement, magnitude of the displacement in the direction of the force. In the direction of the force, we have simple h, mgh. This is the work I should do in order to bring the object from A to B. In order to bring the object from A to B, this is the work I should do. එහෙමනම් අපි කියනවා, then we say, therefore, the potential energy is stored in the object when the object is simple h height from the potential energy zero level is mgh කියලා. ඒ කියන්නේ මෙතන ඉඳන් මෙතනට ගේන්න කරන්න ඕන work එක we refer in another way, it's the potential energy if the object is placed at a simple h height. From a simple h height, from the simple h height, the work that you should to bring the work that you should do in order to bring the object to capital B level, or as the potential energy zero level. That work magnitude is the one that we consider as the potential energy when an object is placed from the potential energy zero level at a simple h height. ඒ කරන්න ඕන work එකේ magnitude එක තමයි potential energy එකේ magnitude එක. But measuring from the potential energy zero level. If we are measuring in the upward direction from the potential energy zero level, we say that this is a positive potential energy. If we are measuring the potential energy in the downward direction, we say that it's a negative potential energy. That's it. ඔන්න ඕක තමයි note එක. Understood. Clear with that? Confirm me through the chat box. I need individual responses. Everyone clear? 100%? Confident? Sure? හරනේ? Okay. That's the thing. Right. තම ගණන් හැදුවේ ගණන් හදන්න, first of all we have to finish the theory. Write the subtopic kinetic energy. 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 Right. Below that, put a star mark and write. Below that, put a star mark and write. Below that, put a star mark and write. The energy stored in an object due to the energy stored in an object due to its motion. The energy stored in an object due to its motion. The energy stored in an object due to its motion. The energy stored in an object due to its motion. Due to its motion. The energy stored in an object due to its motion. Due to its motion. Due to its motion. Due to its motion. is kinetic energy, is kinetic energy, is kinetic energy, is kinetic energy, is kinetic energy. Okay, is kinetic energy. Right, is kinetic energy. Put another star point. Put another star point. Separately put another star point. Example. Example. Example කියලා write like this. Write like this. Imagine a particle gains capital V velocity. Imagine a particle gains a capital V, a simple V velocity. Simple V kamuko. Just to make our equation beautiful. Okay. Imagine a particle gains a simple V velocity. Simple V velocity from zero by traveling a simple S displacement, by traveling a simple S displacement, by traveling a simple S displacement, by traveling a simple S displacement at a constant acceleration simple A, 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 due to the force applied onto the particle capital F, due to the force applied on the particle capital F, due to the force applied on the particle capital F, capital F. Capital F. Now listen. We are imagining a situation where there's a particle reaches its velocity from 0 by traveling a simple S displacement, by traveling a simple S displacement at a constant acceleration. It reaches simple V velocity. It gets simple V velocity due to the force capital F. Due to the force capital F. Force එක නවත්තන්නේ නැහැ. We are discussing about a particular instant. හරි. ඔහොම එකක් තියෙනවා. Draw this one quickly. This is the idea. So quickly draw this one. ගාදින්ටක් ගාලා. Quickly draw this one. Quickly draw this one. Quickly draw this one. Right. Now you're going to develop with me. You're going to develop with me to the M to this M object. To this M object, I'm going to apply in this direction F equals to MA. F is a vector, so this is a vector equation, so mark them as vectors. This is a vector equation, so mark them as vectors. So the magnitude of this F force is capital F. This is the formula. I'm going to make a formula. F is F, weight of the object is M, acceleration is A. Acceleration is A. We'll take it as the first equation. Acceleration is A. We'll take it as the first equation. To the same object, capital simple M, in this direction, I'm going to apply v squared is equals to u squared plus 2as formula. දැන් මේ formulas දෙක දන්නේ නැහැ කියන්න එපා. Right? I'm applying in this direction. So final velocity is v squared, so v squared, initial velocity is 0 because it's starting from rest, plus 2as. 2as. So this one will give you here, I will subject as puta, will subject s, so we get half v square. We'll take it as second equation. I'll take it as second equation. Harada. Second equation. Now I'm going to calculate the work done by the force. Work done by the force. We'll take it as capital W. How to calculate the work done by the force in order to move the object from this point to, I'll take it as capital A to capital B here. In order to move the object from A to B, how to calculate the work? What's the definition of work? Magnitude of the force multiplied by the what? Magnitude of the force multiplied by the කියපන් type කරලා දාපන්කෝ බං chat box එකේ. දැන් මම මේක කියන්නේ මට ඇහෙන හින්දා නෙවෙයි. I want you all to recall it. Multiplied by the component of magnitude of the component of the displacement in this direction. Magnitude of the component of the displacement in this direction. Right? F times S. This is 3. And the direction displacement is S. We know from 1. Capital W is equals to F equals to MA S. From 2, we know A is equals to half V squared. So W is equals to M times half V squared. So we get W is equals to half MV squared. The work we have to do in order to bring the object from one point to another point, okay, by the movement එකක් කරලා ගෙනෙද්දී, due to its velocity, the energy due to its velocity, the energy stored in the object is going to be the half mv square, which is the kinetic energy. Kinetic energy, දැන් පුතා ඔයාලා මතක තියාගන්න, work and energy are two different things නෙවෙයි. Work is something we do in order to complete a task. අන්න ඒ work එක කරන්න help කරන එක්කිනා තමයි energy. So basically, this is how we now go through the division. In order to bring an object from simple h height, from the simple h height to bring the object to this potential energy 0 level, the work you should do is called as the potential energy. Right? To get a simple v velocity from 0, right? The work you should do by making a displacement to the particle, that is what we call as the kinetic energy. And a කරන්න ඕන work එකට තමයි කියන්නේ kinetic energy කියලා. Right? Simple. So basically, kinetic energy is a result of work. That's why I told you in the beginning. Once the work, the ability to do the work is referred to as the energy. Once the work is done, energy is transformed from one form to another form. Right? Okay. So understood, clear with that, drop a message in the chat box. I need individual responses. I need individual responses. Quickly draw a message. පට්ට ලේසිය මේ පාඩම තව එක පාර්ට් එකයි ඉගෙන ගන්න තියෙන්නේ. Once we studied that, the whole lesson is done. ඊට පස්සේ ඉතින් දිගට හරහට past papers තමයි කරන්න තියෙන්නේ. All right. Right. Put a star mark and write. Below that, put a star mark and write. Put a star mark and write. According to this, according to this, according to this, according to this, when an object moves at a simple v velocity, when an object moves at a simple v velocity, simple v velocity, when an object of mass simple m, when an object of mass simple m, when an object of mass simple m moves at a velocity simple v, velocity simple v, simple v, simple v, put a comma, it stores a kinetic energy equal to half mv square, half mv square. So v is the velocity. So not always you get the v notation, you humble nuts puluwa. Okay, right. Okay, no? Right. Harane. Then write, identifying a relation between, then write, identifying a relation between, not a subtopic below kinetic energy only, under kinetic energy it's a subtopic, identifying a relation between, kinetic energy, identifying a relation between kinetic energy and work. Identifying a relation between a kinetic energy and work. So again, draw this figure. Quickly draw this figure. Make andintak gala, but instead of initial velocity u, initial velocity 0, write the initial velocity as 0, as u. Take the initial velocity as u. Takal andinnaku. පුතා මේක මේ horizontally ඇඳෙන්න ඕන මගේ අතින් පොඩක් ඇදේට ගිහිලා draw it again. We are applying a capital F force, u, right? It's get simple v velocity, acceleration s. Okay. Okay. Right. Draw this quickly. right. Now, here's a yeah. To this simple M object, in this direction, I'm going to apply F equals to MA. This is a vector formula, so I will write in vectors. So F is capital F, M, acceleration is A. This is my first equation. This is my first equation. So same as the previous calculations to this M, in this direction, we are going to apply V squared is equals to U squared plus 2AS formula. 2AS formula. Final velocity is V squared. Initial velocity is U squared plus 2AS. So I will take this AS as a subject. So we get V squared minus U squared divided by 2. Let's give these two separately. Half of V squared, half of U squared. We'll take it as second equation. So to the same M, work done by the force. Work done by the force. We get work is equals to done by the force. I'm going to use here, see. What's the work done by the force? Force multiplied by the displacement S. Capital W. Force is equals to MAS. Right? This is from 1. Then work is equals to MA is equals to half V squared minus half U squared. This is from 2. This is from 2. Now, capital W is equals to give this M inside half MV squared minus half MU squared. මොකක්ද මේ ඇවිල්ලා තියෙන්නේ? Kinetic energy difference, no? This is kinetic energy difference එකක් තියෙන්නේ. Kinetic energy change. Kinetic energy change. Right? Final kinetic energy minus the initial kinetic energy gives you the work that you should do in order to bring the object from this point to this point. Capital A to capital B. Therefore, we can say work and the kinetic energy relation is work is equals to difference of the kinetic energy. E K. Kinetic energy idea. Work is equals to difference of kinetic energy. This delta notation is for the difference in this case. Difference, difference of kinetic energy. Very good. We have the difference. Right. Work is equals to difference of the kinetic energy. Right. Quickly do this calculation. Quickly do this calculation. Quickly do the calculation. ඉවරයක් කරලා දාන්න. Quickly finish it. Right. Okay. හරි. එහෙනම් Below that, put a star mark and write. Below that, put a star mark and write. According to this, so I think from 2026 batch only Aisha is missing. Aisha ne. Anith okkomala inna. Right. Lianna. According to this, according to this, according to this, according to this, the work done by the force, the work done by the force, the work done by the force to bring the particle from A to B, the work done by the force to bring the particle from A to B is the change of the kinetic energy, is the change of the kinetic energy, is the change of the kinetic energy, or is the difference, or as the difference, or as the difference. හරි පට්ට ලේසි පාඩමක් ඈ ලකුණු 25ක් බෝනස් projectile is also the same thing පට්ට ලේසි right දැන් ගණන් හැදෙද්දි ඔයාලට තේරෙයි අමාරු වෙන්න ගන්නේ below 2017 වලින් පස්සේ පොඩ්ඩක් අමාරුයි ගණන් එච්චරයි but when it comes to your syllabus it's very easy so I was going through the applied maths paper I didn't send you the applied maths paper I forgot it මට ඊයේ paper එක ඉවර වෙලා පැයක් ඇතුළත මට paper එක ආවා හරි so in applied mathematics paper එකේ the parts that we have completed so far ඒ කියන්නේ අපි පන්ති හදපු ගණන් වලින් පිට ගාණක් ඇවිල්ලත් නැහැ right pure maths paper integration එහෙම පට්ට ලේසි right the figures looks complicated in differentiation අර මේ practical application මේ figure එක අමුතුයි but the same thing හරි pure paper quadratics and polynomials modulus කැලලක් ඇවිල්ලා තිබ්බා මොකද show that r minus ss modulus for this one we already discussed an idea නපුත මේකට අපි කතා කරලා තියෙන idea එකක් you have to consider r minus ss square so this gives you r squared minus 2rs plus s squared so this gives you r plus s complete square minus 2rs minus 2rs no? So r plus s squared minus 4rs this is r minus s wala complete square if we take the square root the square of a square root we have to write the modulus this is equals to square root of r plus s complete square minus 4rs දැන් මුට r plus sy rsy දුන්නු data වලින් ගන්න විතරයි තිබ්බේ මේක කරපු නැති උන් හිටියා මේක කරපු නැති උන් හිටියා A level වල right practice right so in one of our papers essay paper එක මම fully ගන්නේ 2025 A level paper එකකින් මම ගන්නවා නැත්නම් ඒක will discuss as exclusive paper it's better right write the subtopic law of conservation law of conservation of mechanical energy law of conservation of mechanical energy law of conservation of mechanical energy law of conservation for mechanical energy law of conservation of mechanical energy law of conservation of mechanical energy right so quickly and the draw this figure with me Draw this figure with me. Yeah? This is potential energy zero level. Potential energy zero level. So at a simple H1 height, at a simple H1 height from the ground level, a simple M particle can weight mg is projected straightly up at a u velocity. Projected straightly up, vertically up with a u velocity. I'm going to consider an instant in the middle of the journey. Zero. I'm considering an instant in the middle of the journey where the velocity is v. Still the weight is mg. The height from the level ground is, or as potential energy zero level is h2. Height h2 කියලා. Height is h2. h2. හරි. And project කරන්න නැතුව අපි will take it by a force. Without projecting, we'll take it by a force. Project කරොත් මොකෝ වෙන්නේ මේ velocity එක අඩු වෙන්න ඕන because it's going against the gravity. So it goes against the gravity but by a constant p force. By a constant p force if I am taking මොකක්ද වෙන්නේ acceleration එක වැඩි වෙගෙන like rocket එකක් යනවා වගේ. Right? Right, quickly draw this. Finish drawing this. මේ කැමරා එක ඇදේ ගිහිල්ලාද නැත්නම් මං ඇඳපු එක ඇදේද? මං ඇඳපු එක ඇදේ. Quickly draw this. This is potential energy zero level. Potential energy zero level. Below that, put a star mark and write. 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 Let's assume that below that, put a star mark and write. Let's assume that the object with weight simple m, or as object of weight simple m, let's assume that the object of weight simple m, let's assume that the object of weight simple m, the object of weight simple m, object of weight simple m is at simple h1 height from the potential energy zero level. Is at simple h1 height from the potential energy zero level. 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 Full stop. On the object, the conservative force mg on the object, the conservative force mg on the object, the conservative force mg, 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 mg, and another force capital P, and another force capital P, and another force capital P, conservative force mg, and another force capital P inside the brackets, right? In the vertically upward direction. In vertically upward direction, close the brackets. Another force capital P in vertically upward direction, close the brackets. In vertically upward direction, close the brackets. Are acting on the object, a conservative force mg, and another force capital P inside the brackets in vertically upward directions are acting on the object. Are acting on the object. Are acting on the object. When the object is at h2 height from the potential energy 0 level, when the object is at h2 height from the potential energy 0 level, when the object is at h2 height from the potential energy 0 level, from the potential energy 0 level, the velocity is simple v. The velocity is simple v. The velocity is simple v. Separately write. Let's consider the work done by the, let's consider the work done by the forces. Let's consider the work done by the force. Let's consider the work done by the forces. Work done by the forces. Okay, let's consider the work done by the forces. Right, now listen. We know that according to the relation we got here, right? According to the relation we got here, work is equals to difference of the kinetic energy. Difference of the kinetic energy. Right? In the first discussion, we discussed that the work we should do in order to bring a particle which is at simple h height from the potential energy 0 level, okay, to the potential energy 0 level is mgh. What is it? The work in order to, here see, the work I have to do in order to bring this particle with the mass simple m from this level to the potential energy 0 level is mgh1, no? Methana indam geenna mgh2. The work I should do in order to bring the particle from here to here is mgh2. The work I should do to bring the particle from here to here is mgh1. So the total work, what's the total productive work I should do in order to bring the particle from here to here? Methana indam methanata geenna mg h2 minus h1. h2 minus h1. That's the amount of work I should do in order to bring the particle from this point to this point. What does it mean? In other words, when I am taking the particle from h1 to this level, from h1 level to this level here, the potential energy it is gained is going to be mg this height, no? mg this height. This height is h2 minus h1. ඒක තමයි ලියලා තියෙන්නේ. Right? Okay. Is that the only work? Ane naya puta. That's the work done by this conservative energy. There's another one, no? P කියලා එකක්. උගින් වෙන work එක අඩු කරන්න ඕන. Right? We'll have to subtract its work, no? A minus capital P times. Was the work done by a force? Was the work done by the force? Force multiplied by the displacement in that direction. From this point to this point, displacement is h2 minus h1. h2 minus h1. This is the work done by the forces. This is the work done by the forces. Why I am subtracting? Why I am subtracting? අපි හිතන්නේ මෙතන ඉඳන් මෙතනට ගේනවා කියලා හරි. How do we think of the work? Thinking that what if I am bringing this one particle is practically moving in this direction. But how to calculate the work? Thinking that I am bringing the particle from this point to this point. එතනින් තමයි potential energy calculate වෙන්නේ. So in this direction the force is minus. That's why it's minus. Okay? That's why it's minus. Sorry, මේක අනිත් පැත්තට. Sorry, my bad. Particle is moving in this direction. No? P times h2 minus h1. No? h2 minus h1. මං අනිත් පැත්තට ලියනවා. Sorry. Puta, is my video stuck? Oh, මාව පේන්නේ නැද්ද? My connection is unstable කියලා එනවා. My audio clear, right? Is my audio clear? Right. Video is not blurred, right? Sorry, yeah. In this direction, the particle is moving in this direction. Sorry. The particle is moving in this direction. The work done by the force is going to be what, Puta? The work done by the force is force multiplied by the displacement. Component of magnitude of the component of the displacement in this direction. What is it? h2 minus h1. This height h2 minus h1. This is the height. Right? Now, I am going to subtract. I am subtract karanne. We have to subtract the potential energy, no? Why we are subtracting the potential energy? Why we are subtracting the potential energy? The work done by the P force is in this direction, but the work done by the mg force is in the other direction, no? Work done by the mg force is in other direction. Right? The work done by the mg force is going to be what? The force multiplied by the difference of the heights, or else this height. This is the work. We know the work is equals to difference of the kinetic energy. Difference of the kinetic energy. Final kinetic energy half mv squared. Initial kinetic energy is half mu squared. Half mu squared. Half mu squared. Okay, no? Right? Done. Harane. Now remove the brackets. P h2 minus h1 minus mg h2 plus mg h1 is equals to half mv squared minus half mu squared. So I will rearrange it. mg h1 minus mg h2 plus p times h2 minus h1. This is equals to half mv squared minus half mu squared. Right. After this, there's an important discussion that we are about to discuss. Finish until this point, will you? Finish until this point, will you? Finish until this point, will you? Finish until this point. What if Okay. What if we do not put an external force by ourselves? By our side, if we are not putting an external force, if the force is 0, then this P times H2 minus H1 term is going to be 0. Then we get mgh1 minus mgh2 is equals to half mv squared minus half mu squared. ඔහොම එකක් එනවා. Half mv squared minus half mu squared. If I am not putting what? If I am not putting an external force to the object other than the conservative force. Other conservative force is already there. මම අමතර එකෙක්ව දාන්නේ නැත්තම්. Then can you see if I rearrange this, I'll take this minus half mu squared to the other side, this minus mgh2 to this side. We get mgh1 plus half mu squared is equals to mgh2 plus half mv squared. Make out the way. What did we get? Aputa, conservative law of conservation of mechanical energy. Mokakde. Mechanical energy, two types we are discussing in our syllabus. What is it? Potential energy, gravitational potential energy and the kinetic energy. The total energy that it has at this point, if I am not putting an external force, the total energy it has is mgh1 and half mu squared. No, the potential energy and the kinetic energy. When it is at this point, the total energy it has, if I am not putting an external force, what is it? The potential energy mgh2 and the kinetic energy half mv squared. What this equation says? This equation says that if we are using only the law of conservation of energy is applicable for any type of energy. Methanadi, we are discussing about mechanical energy only, right? The mechanical energy is a constant irrespective of the position of the particle. Particle ko kontana tibba bona magule tibbat. Okay, the mechanical energy is a constant. I mean the total mechanical energy. Total mechanical energy is a constant. So there are two messages in the chat box. Sometimes the video becomes blur, sir. Okay, audio is clear, Kino. So I'm screen recording it separately from my end. So audio notes, mama recording ka. Okay. Right. Write this one. Finish that one. Finish that one. And then put a star mark and write. Below that, put a star mark and write. Below that, put a star mark and write. The above result is the above result is the above result is referred to as law of conservation of mechanical energy. Law of conservation of mechanical energy. Now below that in red color pen write. 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 Below that, in red color pen, write. Put a star mark and write in red color pen. Law of conservation of mechanical energy. Law of conservation of mechanical energy. Okay, below that, write the mechanical energy as a law in sentences. Lianna, right. According to the law of conservation of mechanical energy. According to the law of conservation of mechanical energy. Actually, here also puta again a reminder. The law is law of conservation of energy. Mechanical energy we can use it for any energy according to the scientist anuwa. This is generally for any energy we can discuss, but mechanical energy can discuss because in our syllabus we are discussing only the gravitational fields and two mechanical energies, potential energy and this one, kinetic energy. That's why I'm specifying everything to our syllabus. That doesn't mean our physics පැත්තෙන් ගත්තාම මේක තව පොඩ්ඩක් deeply කතා කරන්න පුළුවන්. Right? So law of conservation of mechanical energy. Below that, right? According to the law, again you don't have to write the full. According to the law, 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 if the non-conservative force, if the non-conservative force according to the law, if non-conservative forces, if non-conservative forces does not perform any work on the object or the system. It can be an object or we can have a system also. According to the law, if the non-conservative forces are not performing any work on the object or the system, Putakama, the sum of the potential energy and the kinetic energy, the sum of the potential energy and the kinetic energy is a constant. Sum of the potential energy and the kinetic energy is a constant. The balanna, in this system, this is a conservative force. In the figure, mark this. This is a conservative force. This mg. This is a non-conservative force. Make a non-conservative force. If the non-conservative force is not performing any action, not performing any work, then the sum of the potential energy and the kinetic energy is a constant. Okay, it's a constant. That's the idea. Okay, that's what we call law of conservation. Right. Law of conservation of mechanical energy. Right. එහෙනම් ලියන්න subtopic එක power. Now write the subtopic power. We discussed work, we discussed energy. Now we are discussing power and then question discussion. Write the next topic, power. power. Next Wednesday, I'll be finishing impulse and momentum, impulse and collision lesson එක, right? ඒක කතා කරොත් in your applied paper, very first question from impulse and collision එක කරන්න පුළුවන්, and then fourth question is from work, energy and power, short question paper එකේ. I can't remember the question number, but projectiles question එක කරන්න පුළුවන්. So one question is from this. මම මෙහෙමවක් කරන්න. Impulse and collision next week. Anyway, last Wednesday we are doing impulse and collision. Today work, energy, power. We already completed vectors, and then this one, equilibrium ඒකෙන් ප්‍රශ්න දෙකක් එනවා, jointed rods and equilibrium system of coplanar forces වලින්, right? So මෙතන පහයි, right? Impulse and collision, projectiles, vectors, equilibrium of system of coplanar forces and system of coplanar forces වලින් දෙකයි, jointed rods included. තව මොකක්ද කරන්න පුළුවන් අපිට? තව මොකක් හරි එකක් මම මිස් කරා. Somewhere around 6 questions or something you can do at the end of this month. Essay paper එකෙන් complete 2 essay questions, and next month we are discussing statistics. So එතකොට 3 essay questions you can do from the pure applied paper. Pure paper එක නම් complete කරන්න පුළුවන්. ඔයාලට almost like 9 short questions and 5 essay questions you can complete in pure paper by the end of December. හරි, වැඩ කරන්න ලෑස්ති වෙන්න විභාගෙට. Right, next week you have the term test. Okay, next week you have the term test happening on Wednesday pure paper, Thursday applied paper. Wednesday නෙවෙයි, sorry. Tuesday pure paper, Thursday applied paper. Tuesday pure paper, Thursday applied paper. Tuesday pure paper is, while the pure paper is happening for 27 A-level batch, I'll be doing a seminar for them, discussing the inequalities and modulus functions. For you guys, you will be having the pure paper parallelly happening for you guys Tuesday morning. And Thursday, applied paper යනවා ඔයාලට. Okay, applied paper is happening. So it's a complete paper, 3-hour papers යන්නේ. So get ready for the exam and come. Right. That's the grade 12 third term and grade 13 first term එකේ mix කරපු එකක් එන්නේ. Basically grade 13 first term කියලා හිතන්නකෝ. Right. Next, write the subtopic power. Write the subtopic power. Write the subtopic power. Okay. Power. Below that, put a star mark and write. Below that, put a star mark and write. The rate of doing a work. 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 The rate of doing a work is referred to as power. The rate of doing a work is referred to as power. Below that, put another star point. Unit of power is joules per second, which is capital W, watt. Unit is joules per second, which is a single unit, capital W, watt. Usually power එක මනින්නේ watt වලින්. Work and energy we discuss in joules. Right. Now below that, put another star point and write. Below that, put another star point and write. Let's take power as capital P let's take power as capital P. Let's take power as capital P and work as capital W. Put another star point and write. Let's take power as capital P and work as capital W. If there are any 2027 batch students, මෙන්න මෙතන කරන proof එක sometimes you might not be able to understand, but proof is not that needed. We are discussing about the we are going to use the formula only in calculations. හරි? Proof එක එච්චර වැදගත් නැහැ. Right. Put another star point and write. Put another star point and write. Let the power be capital P and the work be capital W. What's the definition of power? Power is the rate of changing of work. Rate of changing of work. Rate of changing. How do we calculate a rate of changing? Rate of changing calculate karanne by differentiating it, no? By differentiating it with respect to what? Time. Change with respect to time, no? If we are calculating a rate with respect to time. Rate of changing of work is with respect to time. It's a differentiation, right? It's a differentiation. For an example, this is the work, this is the time. With the time, I record the work. With the time, I record the work. Right? At this point, if I draw a tangent, at this point, if I draw a tangent, the tangent's gradient, which is dw over dt, gives you the power. This gives you the power. Okay. Now here see, we know that P d over dt, we know work is given by force multiplied by the displacement component in the direction of the force. Displacement component in the direction of the force is also a displacement, no? Right? Also a displacement. මම ඉතින් තනි letter එකක් ගන්නම් S කියලා. I take a single letter as S. Okay. Now what do? We are applying a differentiation for what? To a product. How do we differentiate a product, Puta? First one times first derivative of the second one plus second one times first derivative of the first one. First derivative of the first one. Right? We discuss about constant forces. Work. You see? We are discussing about the constant forces, no? Venas in a force, we don't discuss about moving an object by applying a frequently changing force. Go through the definition and see. What was the very first definition? The work done by a constant force. I'm considering the force as the constant. We are considering force is a constant. Force, capital F, is a constant. Therefore, dF over dt is 0. Why? When we differentiate a constant with respect to anything, the answer is 0. And now P is equals to F times ds over dt. Rate of change in the displacement. Rate of, if I take a displacement time graph, the rate of change in the displacement, it's gradient, no? It's gradient, which is ds over dt. Yeah, velocity. It's the velocity. It's the velocity. It's the velocity. එහෙනම් P equals to FV. ඔන්න power formula එක. P equals to FV. That's a power formula. This is the velocity. Velocity. Remember, when we apply power formula, we apply it for a particular instant, not for the entire scenario. Velocity of the object at a given instant. This is our power. On the power. This is our power. Right? So power is equals to FV. Right. So remember, this important idea is that this F, okay, and V, both of them are, I will write it in red color pen first of all. Ek special note එකක් විදිහට ගමුකෝ. First of all, finish drawing this මේක ඇඳලා ලියා ගන්න for your betterment of understanding. Quickly finish this. Take the note. Take the note quickly. Take the note quickly. Yep. Good. Natasha පොඩ්ඩක් කර class එකේ engage වෙලා වැඩ කරනවා. Good. Right, put a star mark below that and write in red color pen. Put a star mark below that and write in red color pen. Quickly. Put a star mark below that one in red color pen and write. According to this, 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 if the force is constant, according to this, if the force is constant, according to this, if the force is constant and according to this, if the force is a constant and according to this, if the force is a constant and the direction of the force and velocity, the direction of the force and velocity is same, and the direction of the force and velocity is same, velocity is same, velocity is same, velocity is same, put a comma, put a comma, put a comma and write, 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 put a comma and write. The power is given by, the power is given by, the power is given by the product of the magnitudes of power is given by the products of the magnitudes of product of the magnitudes of the force and velocity, products of the magnitude of force and velocity, product of the magnitudes of the force and velocity. The force and velocity. The force and velocity. The force and velocity. Right එහෙනම්. Work, energy and power එකේ theory ඉවරයි. Right? So එතකොට work against the friction like that we have subtopics ඒවා questions වලින් තමයි discuss කරන්නේ. Okay? Right. Work against gravity. Work against gravity only we discussed as the potential energy. Right. Work against friction. We didn't specifically discuss that one. That one we'll be discussing in the questions. All right. So the theory ivarai. Now the time is 10:20. I'll give you a 20 minutes break. Okay. 10:40. I'll be starting the questions discussion. I already sent the tut in the chat box. I will send it again. Mama dannan chat box okay. 1 minute. So complete past paper tute එකක් තමා දුන්නේ. We don't have to discuss any other questions. Past papers are the best resources that we can get the idea. Hari. So I sent you the tute in the chat box. Right. එහෙනම් 10:40 AM we'll be starting to discuss the papers. 1 PM වගේ class එක ඉවර වෙයි. Okay? Around 1 PM class එක ඉවර වෙයි. Sometimes even before that. Right. So you can take a break. 10:40 I'll resume. Take your breakfast, take some drink some water, get fresh up and get back to the session. Okay. I told you Nakif, this part, the derivatives part understand karaganda bari way because that's differentiation. So don't worry about the derivation. Finally we got the formula that P equals to FV formula is there. So that's the only one you need. Okay, right. Is everyone there? Drop me a message in the chat box quickly. I need your responses. Is everyone is in the session? හැමෝම ඇවිල්ලා දින්නේ. Drop message quickly. I need individual response. Okay. Right. Now take the tube. Take the tube and I send the PDF only. Let's discuss from 2024 and reverse. Right. Let me take PDF. I think so also. Right. Question number 1. Start. Try the question. You try the question. I'll give you like 45 seconds to 1 minute just to read out the question and then I'll discuss. Two 2025 short question paper is unavailable for the moment because you will get the paper Once the marks are out, I mean results are out, no? Right. A car of mass n kilograms travels along a horizontal straight road with its engine working at a constant power PW. PW means P watts. So usually what I recommend to the students is if they are explaining a situation by words, they usually don't give you figures. You have to draw a figure by yourself, right? Capital M is the weight actually the mass. Okay, travels along a horizontal straight line road with its engine working at a constant power PW. The power of the engine is given P at a P power. Okay, at a P power. W is the unit now. Power is measured in watts now. W is the unit, P watts. Now what they say, there's a constant resistance. There's a constant resistance. Forgot to put the recording in all these minutes. Right. Now, a car of mass 10 kilograms travels along a horizontal straight road with its engine working constant power PW. There is a constant resistance of R inherent to the motion of the car. There is a constant resistance to the car. In this direction only the car moves. Okay, I'm taking that the car moves in this direction. When the car moves in this direction, if it is moving, we have to give a force, no? I take that force as capital F. Due to the force, the car gets an acceleration and there's a resistance to the motion. It can be an air resistance or it can be a friction. We don't know, just a resistance. A resistance to the motion in this direction, capital R. Resistance is always in the opposite direction to the motion, no? Resistance is capital R, right, to the motion of the car. Find the acceleration of the car at an instance when the speed is u meters per second. When the speed is u meters per second, at this particular instant, they want us to calculate the acceleration. They want us to calculate the acceleration. So we have two formulas in our hand, no? We can't apply the work idea here because we don't know the displacement it has made. But we can go with one law from Newton, right? If there is an object moving due to an imbalanced force, if I want to find the acceleration included formula is F equals to ma. So for the capital M car, in this direction I'm applying F equals to ma. I'm applying a formula. So this is a vector formula mentioned like this. In this direction, what are the forces we have? Someone set up professional. I thought my audio is clear, right? You can hear me, right? audio my audio is clear, right? Drop a message in chat box quickly. Right. So in this direction, what are the forces we have in this direction? The F force we put in the direction of the motion and the resistance. Resistance is in this direction, minus R. This is physics. In this direction, the imbalance force is F minus R, right? In this direction, what's the imbalance force? What is the resultant force in this direction? Capital F minus R. This equals to mass of the car is capital M. We need to calculate the acceleration. The thing is, R is given data, M is a given data, F and A both unknown. Right? So I'll divide both sides by M. So we need to calculate the acceleration. Acceleration is equals to capital F minus R times 1 over M. Or as I write like this, 1 over M times capital F minus R. I will take it as first equation. In order to find A, I need the capital F value. I need the capital F value. Now, to this vehicle, I'm applying this here to the F car. I'm applying P equals to Fv formula. Power is equals to F force times P. Now the special note that you need to know. Huda, when it comes to this force, this is the force actually put by the engine. Why is that? In Sinhala we say the Prakarshana Balaya. Okay? The engine's force. You don't substitute P equals to F minus R in here. Make another F minus R times P. This is wrong. We put what put the we put the only the force that given by the engine. Why is that? What is P? P is the power. The power is generated in a vehicle. We are discussing a practical context. The power is generated in a vehicle by its engine. The vehicle is moving because of the engine works. This F force is put by the engine actually. F force is the vehicle and engine. Nobody is pushing from behind. Engine is in start. Engine gives this power. Due to this power only this force is working or this force is applied. P equals to Fv formula. They gave you the power as capital P, force we have taken as F. At this instance, the velocity is U. So we get capital F equals to P over U. This is 2. From 1 and 2, we get acceleration is equals to 1 over m times P over simple U minus R. Okay, if you keep the answer like this, still you will get marks. Then you talk about all the marks allocated how they have allocated marks. For the moment, here see, applying this formula here properly applying within 5 marks, and then they have given F equals to ma for this proper substitution 5 marks, and then getting the acceleration 5 marks. So this is how the marks are allocated. Okay, so keeping the answer like this is enough. Now what they ask next? Right. Now the car travels at a constant speed up a straight road that is inclined at an angle theta. Now the second is better to draw another figure. At this inclined plane, okay, at an angle theta, okay, theta to the horizontal, finds the constant speed which the car is subject to the same resistance R Newton. Car is subjected to the same resistance. Here they want us to calculate the velocity at this instant. Okay, constant speed. They want us to calculate the constant speed. Constant speed means acceleration is 0, no? Constant speed means acceleration is 0. Constant speed. Speed is not changing. If speed is not changing, what does it mean? Acceleration is 0. So each word is important. The car travels at a constant speed up in the inclined plane. Constant speed up. Applied mathematics is easy if you draw the figures. Draw the diagrams. Diagrams only will give you the proper forces. Proper marking of forces you can understand only from the diagrams. So the same M. Because this goes in an inclined plane. This goes in an inclined plane. So there is an effect from the weight also, right? So weight is mg. Capital Mg. This is theta. This is 90 minus theta. If I draw a perpendicular line here, this is theta. Then the component of the weight in this direction is mg cos theta. The component of the weight in this direction is mg sin theta. Right? So in this direction here, the car is moving in this direction. Car is moving. Move whenever. Which means because of the P watt, because of the P watt power, the car is getting a force from the engine. I take it as F1. It's not going to be the same force as this. It's going to be different force. So you will have to use a different notation. Be practical in everything. But the car is subject to the same resistance, capital R. Same resistance, capital R. Right? Same resistance, capital R. Practically speaking, there is one more force we need to add. But I'm not going to add. If you want, you can draw that here. See? The normal reaction force, I will take it as S. Normal reaction force is acting. But for the moment, normal reaction force's impact is not required. Because we are going to apply formulas in the motion's direction. I'm not going to mark the normal reaction force. We'll just mark it. Easy enough. So to the inclined plane, at a theta angle in this direction, I'm going to apply F equals to ma. In this direction, I'm applying F equals to ma. Now listen carefully. In this direction, if we apply F equals to ma, what do we have? F1 force put by the engine, the driving force, minus capital Mg sine theta minus capital R equals to M. A is c. Why is that? Constant speed. Speed is c. Acceleration is 0. So we get F1 is equals to F1. They're asking us the velocity of F1 is equals to mg sine theta plus capital R. Plus capital R. I'll take it as third equation. Now, to the vehicle again, I'm going to capital P equals to Fv formula. P equals to Fv formula. What is it? Same power, but the force is F1. What's the velocity? What is F1? Mg sine theta plus R. So P is equals to mg sine theta plus R times P. So the velocity at this instant is given by capital P divided by mg sine theta plus capital R. Our unit is going to be ms minus 1 answer. 1 answer. Right? So the marks are allocated like this. 5 marks for this F equals to ma formula and 5 marks for the final simplified answer. But without writing all this, if you could try to get these marks, it's about a production okay, because marks you'll have to show the calculations to final mark that doesn't mean none of these steps required, all the steps are required. Okay, basically this is the short questions 25 marks. Please think about if P equals to ma, P equals to F, P equals to ma, P equals to F. Properly identify the forces is the important. Draw the figures and do one. Draw the figures and do. Carefully draw the figures and do. Finish it. Finish it. Right? And then try 2023, 22, 21. Then try කරන්න අක්කල එසීම ගණන් දෙකක් තුනක් සතදී දෙකක් තුන නෙවෙයි එකක් හැදුවොත් everything is C. But you do it. Drop a message in chat box. Isn't it easy? Make it difficult the easy. What's your opinion? I then applied to number lazy make it. Finish it. Do the simplifications carefully. Identifying the forces is the important one. Sorry. Right. Shall I erase the board? Shall we do the next question? You guys try. Or try that. 2023, 22, 21 finished it. Once again, a reminder, your revision is starting on December first week, okay? So I didn't do any promotions yet. If any of your friends are willing to join, and if you guys are really want to join. Here to the other. Revision is another major class, a big class. ඒක මම මේ theory class package එකකට දාලා like paper class වගේ theory class plus revision class එකම combine කරන එකක් නෙවෙයි. Okay, so theory plus paper we give a discount, no paper only separately. Theory plus paper is another product like that. So but revision and paper a පිටලමයින්ට I might give some small discount. But revision and theory, I'm not going to give any discount. Okay. Because I want the theory class students to properly work in the theory class. Financial difficulties, but it won't keep my problem. What? Right. So what about this? What I'm saying, you have to save your time first. Revision my theory classes are Tuesdays, Sundays, and the paper classes on Friday. Right? Again, our seminar series are happening on Thursdays on day. But tomorrow. Revision okay. If you really want to cover up the missed parts, and if you really need to come for a theory class and revision class and do another okay. But the fee is going to be almost same as a theory class fee. Alright. I need the revision, but I can't afford it. Personally contact हमारा भी साली सवाल से एक के बाद ये नहीं अरे बड़ा करने तो कम थी पर एक के बाद में अरे right 2023 AN they say that a bag of mass 1000 kilograms is traveling along a straight horizontal road 1000 kilograms vehicle लेगा so 1000 kilograms bag travels along a horizontal road. The road is a horizontal road. Okay. Horizontal road against a resistance of magnitude 800 Newton. Resistance of magnitude. I'm taking it's going to travel in this direction into a resistance is 800 Newton in the other direction. Right? Opposite to the direction that the vehicle travels. If you are taking the vehicle goes this way, the resistance is in this way. Right. 800 Newton. Find the power of the engine of the van when it's traveling with a constant speed of 50 meters per second. Constant speed, then the acceleration is 0. The speed is 50 meters per second. Constant speed means speed doesn't change. The vehicle is moving means there should be a power. Power is a captain of vehicle. There's a power generated by the engine. Due to the power, there's a force in this direction. There's a force in this direction. So for the vehicle, for the van, I'm going to apply F equals to ma the vector formula in this direction, vector formula. Okay. So I take the force in this direction, F minus 800 is equals to If mass of the vehicle is 1000 times acceleration is 0. So the F key 800 Newton. So the force given by the engine is 800 Newton. Force given by the engine is 800 Newton. So if I am applying P equals to F formula, power is the one they wanted us to calculate. Okay. Power is equals to F is 800. At this instant, the velocity is 50 meters per second. Everything is given in standard SI units. 800 is in newtons, 50 is in meters per second. So power will be in watts. Everything is standard SI units. Now, watts in case if the speed, this one is given in newtons, but the speed is given in kilometers per hour. If the speed is given in kilometers per hour, then this product is not going to give you the power in watts. Watts only comes again there. Then what you have to do, this kilometers per hour, you have to convert it to meters per second and something. You have to be very conscious about the units. Right? So that's why you get the training in physics. So with 800 newtons multiplied by 50 meters per second, SI unit of velocity. 800 Newton, SI unit of Newton. Then the product of these two gives you the SI unit of power, which is watt. So the answer will be in 5 times 4 is 40. P equals to 40,000 watt. Units are covering the 80,000 watts. Okay. So don't keep it as P. On let power be P kilogram. That's better. Let power be P kilogram. Now next what they say. Now the van travels along a straight horizontal road against a straight horizontal road. Still, it's traveling against a straight horizontal road. But the situation is different. Now the van is traveling along a straight horizontal road. The 1000 kilograms vehicle against a resistor 800 plus 4V Newton. Okay. Newton, where Vms minus 1 is the speed of the van. At this instant, the speed of the van is Vms minus 1. Find the acceleration of the van at this instant. There is an acceleration. Main instant in acceleration, let's take it as A. Okay, I'm taking the acceleration as A. At this instant, when its speed is 20 meters per second. At the instant when the speed is 20 meters per second, when the V is 20 meters per second, they are asking. When the speed is 20 meters per second, if the van, if the engine of the van is working in the same power, power is going to be the same 40,000 watts. Power is going to be the same 40,000 watts. But the force is going to be a different force. I will take it as F1 or F dash. I take it as F dash. Right. In this direction, I'm going to apply F equals to MA. The force is going to be F dash minus 800 plus 4V. 800 plus 4. What is V? V is given 20 meters per second. At that instant, they are asked. This equals to weight of the van is 1000 kilograms times acceleration is A. So this gives us F dash minus 4 times 2 equals to 880 is equals to 1000 A. So I divide both sides by 1000 and subject A. A is equals to this one divided by 1000. So I need to find A, the F dash. I'll take that first equation. For the vehicle, let's apply P equals to Fv formula. Power equals to force times velocity. Power is 40,000 watts. Power is 40,000 watts. This equals to F is F dash. We have to calculate the power by the force by the engine times velocity is 20. So this gives you 0 and 0 cancelling out. 4,000 divided by 2 is 2,000. So F dash is equals to 2,000 Newton. 2,000 Newton. 2,000 Newton. Right. F dash is equal to 2000 Newton. Right. So now what I'm going to do is from 1, therefore, from 1 we get acceleration is equals to F dash is 2000 Newton minus 880 Newton divided by 1000. This one will give you SI unit of acceleration is ms minus 2. Always remember to put the unit. Acceleration is equals to 2000 minus 880. 120 gives you 1000, 1120 divided by 1000. So 1.12 ms minus. Okay, 1.12 ms minus 2. So the mass allocation is like this. Right? Mass allocation is like this. Method force second 5 marks. And then finding the power and let power be P. You have to write this up. Power is 40,000 watts, 5 marks. And then after that, F equals to MA. And this one. Method F equals to MA to this one, 5 marks for the application. And then after that finding F dash 5 marks. Finally finding acceleration 5 marks. This is how the marks allocation is. Right, 2022, 2021, 2020 and 19. 2022, 21, 20 and 19. කරන්න බලන්න. ලේසි යා. දැන් ඉතින් මේක වරද්ද ගන්න නම් එපා exam එකේ. So your voice is low. How about now? දැන් හරිද? You couldn't listen properly or how is it? Fine, right? You were able to hear me, right? Drop a message in the chat box. Voice is low කියලා කියනවා. Now fine. Now fine. Now somewhat okay. Mic එක අවුලක්ද? Let me change the mic and get back to you. Right. How about the audio now? How about the audio now? Drop a message in chat box quickly. Either ඔයාගේ volume එක පොඩ්ඩක් වැඩි කරලා බලන්න. Sometimes device volume එක අඩු වෙලත් දන්නේ නැහැ. Others, drop a message in chat box. How about the audio now? It's clear? Am I audible to you properly? Am I coming through okay? Okay. Okay. Right. Do 2022 question. A car of mass 1500 kilogram with a constant power of 80 kilowatts moves on a horizontal road against a constant resistance. The resistance is not given, so you can take any notation for it. The car of mass 1500 kilograms working with a constant power 80 kilowatts. ඇත්තටම 2019 එකෙන් පස්සේ ප්‍රශ්නත් පට්ට ලේසි කරලා තියන්නේ. So this is 1500 kilograms. 1500 kilograms car working at a constant power 80 kilowatts. 80 kilowatts moves on a horizontal road against a constant resistance. It moves on a horizontal road against a constant resistance. I'll take the resistance as R Newton. Okay. The acceleration of the car is 2 meters per second. Acceleration of the car is 2 meters per second. Right? You see, when I'm using notations, have you noticed that mama acceleration dati double arrowhead dano? I don't know whether in physics they are using this. Not usually. When I was doing A levels and my lecturers even in university, when it is a velocity, they use this this arrowhead. If it is a acceleration, they use this arrowhead just to represent that this is acceleration, this is velocity. එකම arrowhead එක use කරන්නේ නැහැ. Those are not parts that you will get marks, but those are some things that that makes your presentation looks nice. රූප සටහන් ලස්සනයි, diagrams will be nicer, and it will be giving you a clear idea about what you are doing. First of all, before the people who check your exam paper, first of all, you should be able to understand what you have written. The questions are not, these are simple questions, but when it comes to essay questions, not all the questions are small questions, right? Mula karapode aga mataka tiyenna ඕන, and you have to turn the pages and check your findings. So throughout the calculation, if you can't find your own writing, කරන්න බෑනේ, it will take your time. So nicely write down. සමහරුන්ගේ අකුරු තියෙනවා හකුරු වගේ. මෙලෝ රහක් නැහැ. සමහර ගෑන් ළමයින්ගේ අකුරුත් ගන්න දෙයක් නැහැ. Right. When it moves the speed of 20 meters per second. At this instant, the speed is 20 meters per second. Right. Obtain equations sufficient to determine the acceleration of the car. Did they ask you to solve? No. Obtain the equations sufficient to determine the acceleration of the car when it moves upwards on a road of inclination sine inverse 2/3 to the horizontal with speed 8 meters per second with the same constant power against the same constant resistance. The monna magulakda ඔය කියන්නේ sir. So now at this instant, let's say the force given by the engine, let's take it as capital F. Right. Now what they ask, these are the data provided for this instant, but the question is asked for something else. Right. Or I have seen a Instagram reel, or someone called Gopal is dying under the lorry the probability calculation, something like that. So given the data for this, but asking for a instant like this. I will take this angle as theta. The angle of inclination is given sine inverse 2/3. Sine inverse 2/3. Right. So I'm going to take, let sine theta be, sine theta is equals to 2/3. So therefore, if I draw a right angle triangle in this situation, sine theta is opposite side divided by the hypotenuse. So this is 3 squared is 9. 2 squared is 4,
So 9 minus 4 is equals to 5, square root of 5. So this gives me cos theta is equals to root 5 over 3. In case if needed, I will just do it. Right? So theta, it makes the figure looks complicated in the, all right, let theta be sine inverse 2 over 3. We'll take like this. Now the car with 1500 kilograms, what they say in words, try to put them into figure, then you will understand easily. The car of weight 1500 kilograms goes upward direction in a straight road, which is theta angle inclined to the horizontal, right? They want us to find the equation sufficient to calculate the acceleration of the vehicle at the instant when it's moving at 8 meters per second speed. But it's subject to the same resistance and the same engine power, 80 kilowatts, same engine power is given. But the force is going to be different. I will take the force at this instant as 1. In this instant, I will take the force as F2. Force is going to be different. When a force because to the movement in horizontal line, the vehicle didn't have to struggle with or else go against the weight. Weight taking impact. Only the resistance was there. Now, the impact of the weight also coming. Weight is 1500 G. Grams neve gravitational force, or is 15,000 Newton. If I draw a perpendicular line to the inclined plane, this is theta. So this is 15,000 cos theta. In this direction, we have 15,000 sin theta. This is 15,000 sin theta. Okay. So all the forces marked, I don't know whether it's visible for you guys. Lasanta mark karana loku ekak endala. Okay, this is 15,000 sin theta. I don't think that it's visible for you. So I will adjust it. May pattata from the engine F1. Here we have 15,000 sin theta. Right. So actually the normal reaction force is also acting. But in this case, the friction is not included. Therefore, don't worry about the normal reaction force. The idea is to calculate enough equations. Calculate equations that is enough to find the acceleration A. Move hoya ganna ona karana equations ganna kiya. Right? Then why this instant was given to you? This instant was given to you to calculate the R. Why? The same result, same resistance is for the vehicle when it is climbing this mountain. No? When it is climbing this inclined plane, same resistance is there. If I consider this first situation, right, clearly draw the figures, and if I'm considering this situation, horizontal situation, or else draw the figures and I'll consider this as 1, I will consider this instant as 2. It's better. Okay, instant 1. Consider instant 1 and apply F equals to ma in this direction. Why? There is a vector formula. Make sure to write it as a vector formula. If I apply F equals to ma in this direction, we get the F1 minus R is equals to weight is 1500, acceleration is 2. So this gives me F1 minus capital R is equals to 3000 Newton. This is my first equation. We got an equation from F1 and R. They didn't give you the notation R. They say that the vehicle moves on a horizontal road against a constant resistance. moves against a constant resistance. The resistance value is not given. So the R is a notation we put. We need to find the value of R. So F1 is also a notation we put, the force given by the engine. We need to find F1. Then to get this R, I need F1. To get the F1 at this first instance, I can apply P equals to FV formula. No? What is P equals to FV formula for this? The power is given 80 kilowatts. 80 means 80 kilowatts means 80,000 watts. No? Kilo means 1,000. This is equals to F. What is F? In this case, I am taking F1. V is in this instance 20 meters per second. Do we need to simplify? No, Pudha, just write 80,000 equals to 20 F1. Second equation. It's right. Question is to obtain equations sufficient. In equations that is enough to solve the question. Now these two equations are enough to find the F1 and R. I need this R to do the calculations in this. Now let's come to this instant. I'm going to take the instant 2. To the horizontal at a theta angle in this direction, I'm applying F equals to ma. This is a vector formula. In this direction, we have this is F1, this is F2. I make F2 kilagane. F2 minus R minus 15,000 sine theta. Sine theta is known, so ek vitarak substitute karla gamu api. This is equals to 1,500 times A. A is the acceleration we need to find. Okay, A is the acceleration we need to find. Select the acceleration in this instance as A kinetic. No need to write. If you draw the figures, better to draw. Better anyway. Anivareng andappa. Anivareng andinda. And then lakunu denne nadda. Naha kiyala hitagena andinda. Otherwise, how you are supposed to do the calculations? Figure gives me a great help, no? Without having a figure, always you will have to draw the figures and do. Now here, R can be found from these two equations. These two equations is more than enough to find R. Sine theta we know, let's substitute F2 minus R minus 15,000 sine theta is 2 over 3. 15,000 sine theta is 2 over 3. Okay, 3 divided by 3 equals to 1. 15 divided by 3 equals to 5,000. So we get 1,500 A here. So we get F2 minus R minus 5,000 times 2, 10,000 equals to 1,500 A. This is my third equation. In third equation, we have F2, R and A. R is an unknown. No, Putta. R is known from known if you solve these two equations. From these two, by solving these two, by solving this, you get F1. By substituting F1 here, you get R. You can substitute that R here. So we have an equation in terms of F2 and A. I can find this F2. Kohamada. In this instance, apply P equals to Fv. At this instant, apply P equals to Fv. What's P? Same P, 80,000 kilowatts, 80,000 watts. F is F2. At this instance, speed is 8. Do we have to simplify it? No, Putta. Fourth equation. Gana ivarai lakunu 25. Mechara gana. Did they ask us to solve? No. Obtain equations sufficient to get the acceleration. Obtain the equations sufficient to get the acceleration. These four equations are more than enough to get the acceleration A. From these two R and A, unknown is F2 and A. F2 එක මෙතනින් එනවා. Substitute F2, you get A. acceleration at this instance is found. Right? Complete it. Complete it. No need to solve. Solve කරලා වෙලාව නාස්ති කරන්න එපා. In essay paper also, when it comes to relative acceleration lesson, you will see these kind of things. You just have to obtain equation that is sufficient to solve and get the equation sufficient to get a value. So for this one, the marks allocation is Hare. මෙතන එකට 5යි. Okay. Right. මේක ඕන solve කරලා ගන්න පුළුවන් නම් ලිව්වට මේක විතර අර don't solve everything. If you want write this one only F1 equals to 4000 Newton කියලා ලියන්න, no problem. Okay. For this one 5 marks. And then මෙතන මෙතනට 5 marks. ඊට පස්සේ මෙතනට 10 marks. Okay. ඊට පස්සේ මෙතනට 5 marks. Okay. Right. Right. Question number 2021. A car of mass m kilogram moves upward with a constant acceleration along a straight road of inclination sine inverse 1/20 to the horizontal. Right. So there's a car of mass. Methana alpha kilagamu. This is sine inverse 1/20 is the angle with a constant acceleration. This one has a mass capital M. Okay, then the weight is mg, right? A constant acceleration, this 21 al, a constant acceleration. They didn't give you the acceleration, just keep it as I'll take it as simple a. The constant resistance is r Newton to its motion. Resistance is r Newton. Okay. The distance traveled by the car to increase the speed from 36 kilometers per hour to 72 kilometers per hour is 500 meters. So this one traveled a distance, okay, at a constant acceleration at the same with the same resistance r Newton, with the same weight mg. Okay. The initial speed is 36 kilometers per hour. Okay. 72 here 36 kilometers per hour. This is 72 kilometers per hour. Right. So basically twice the velocity. Right. Twice the velocity. But Puta, we have to go with the what? We have to go with the ms -1 unit, no? So kilometers per 1 hour is equals to 60 minutes, which is 3600 seconds, no? 3600 seconds. 1 kilometer is equals to 1000 meters. So how do we take meters per second? If I divide these two, 1000 meters divided by 3600 seconds. These two zeros cancel වෙනවා 5/18. මතක තියාගන්න මේ number එක. Remember this number. I hope you all have you all got this in physics also. මේක physics වලත් හම්බෙලා ඇති. Just remember this number. If you want to convert a speed 36 kilometers per hour to meters per second, just multiply this one with 5/18. This gives you meters per second. Just multiply with this ratio, it gives you meters per second. So 18 divided by 18 equals to 1, 36 divided by 18 equals to 2, 10 meters per second. So make a 10 meters per second. Then 72 should be 20, no? Here, 72 kilometers per hour. This equals to 72 times 5/18. This gives you ms minus 1. 36 වලට දෙකයි නම් මුට 4ක් නේ. 20 meters per second. Then 72 kilometers per hour is going to be 20 meters per second. You have to convert them to SI units and do it. එහෙම නැත්නම් ගණන් වරදිනවා. Right. So the distance it traveled on the inclined plane. They didn't say distance traveled by the car to increase the speed from this one to this one is 500 meters. They didn't say that it's whether it's a horizontal the මොකුත් කිව්වේ නැහැ. ඒ කියන්නේ on the inclined plane 500 meters, the direction of the force. Right. Obtain equation sufficient to determine the power exerted by the car when its speed is 54 kilometers per hour. When its speed is 54 kilometers per hour. First of all, I'll take the force as F. This is going to be a constant force. Force is not going to change. Okay, I'm going to take let power exerted by the car when its speed is 54 kilometers per hour. Power exerted by the car when its speed is 54 kilometers per hour. Okay, right. So let take the power as P and get the equations. This is the situation. Quickly කරන්න බලන්න. Quickly do it. A constant acceleration. Now it's a constant acceleration. ඉවරයක් කළාද? දැන් මෙතන ඕනනම් if you go through the marking scheme, what they have done is they have taken F1, they substituted F1 and they got R ගේ value එක අරගෙන දිනනවා යාලා. They have taken the value of R and then substituted R here. Finally මෙන්න මෙතන විතරක් simplify කරලා දීලා. Instead of substituting taking this one as 15,000, they have taken 1,500 G. So if you ask me, is our answer is wrong? නෑ මේක වැරදි නෑ. We just answer the question. What the question? Get equations in sufficient equations. එච්චරයි. මේක හරි. The presentation is different in the marking. එච්චරයි. Finish it. Harida. Right? Right. Now here see the method keeping this situation. This is 100% right. Huh? So now the figure is like looks complicated. Now this is okay. Make it right? Representing all the situations. If you want, you can write do like this. R Newton constant resistant is like this, and in between this, no, we have 54 kilometers per hour. Here see, so 36 kilometers per hour. If you convert it to speed, meters per second, how do you do it? 36 multiplied by 5/18 meters per second. This is 10 meters per second. Then 72 kilometers per hour. This is going to be 72 times 5/18. 5/18 meters per second. This is going to be 10 meters per second. And then 54 kilometers per hour. 54 multiplied by 5/18. 54 divided by 18 is equals to 3. 15 meters per second. 15 meters per second. So this is 15 meters per second. Again the same M, mg, same R, same F. Kathaine figure. So representing all these, I'll write a general situation like this. Right? මේක තිබ්බට ලකුණු නැද්ද සර් එතකොට? නෑ ලකුණු තියෙනවා. මේකට ලකුණු පහක් දීලා තියෙනවා. For the figure in this year they have allocated 5 marks. For this 2021 year drawing the figure they have allocated 5 marks. But they have completed a simplified figure. Right? Made instant තුනම දෙන one single figure they have mentioned like this. The speed is speed එක අරන් තියෙනවා v කියලා. Acceleration they have taken F. I'll take it as simple A. Resistance is R, capital F, mg, and here we have alpha sine inverse 1/20, and then per normal reaction force. It's not compulsory, but if you draw it, also no problem. If you draw the normal reaction force, also no problem. I'm not going to draw it because the impact of the resistance is not given. So this V can be in one instant 10 meters per second, 15 meters per second, 20 meters per second. Okay. So if you complete all 3 instances in one single figure, also no problem. Or like this, also no problem. Or as if you complete like this, also no problem. Okay. Right. So I will go with this because I can see all the data clearly here. Now, if I'm considering this initial and final situations, which makes a 500 meters displacement, okay, figure eකට 5 marks. These conversions 5 marks දීලා තියෙනවා. 10 marks මෙතනට වෙනකන් දීලා තියෙනවා. Right. Now, to this plane in this direction, at an angle alpha, okay, I'm going to take, we can calculate the acceleration easily because since we don't know F and we don't know the power also, we don't know the force, we don't know the power also. Power is changing at this instant, and this instant. Constant power එකක් නෙවෙයිලු. Right? That's why they asked us to calculate the power at this point. Okay. Then actually in previous calculations also power was not a constant. Power here, power is changing when the situation changes. A particular instant 80 kilowatts. When the velocity is 8 meters per second, 80 kilowatts. At that instant, the force is F2 kg. Now here's here. In this direction, I'm going to take v squared equals to u squared plus 2as. Why? We know the final velocity 20 meters per second, 20 squared. Initial velocity 10 meters per second, 10 squared. Plus 2, I need the acceleration. S is 500 meters displacement, 500. So the acceleration from this we will get 400 minus 100, 300, 300 divided by 1000. We get meters per second per second. So this gives you 3 over 10. Acceleration is 3 over 10 meters per second per second. This is my first equation. This is my first equation. M is minus 2. M is minus 2. Right. This is my acceleration. And we know the acceleration now. Now what I'm going to do is, since we know the acceleration in this direction to the horizontal and an alpha angle in this direction, I'm going to apply F equals to MA. Let's consider the general instant here. See, මෙතන තියෙන හැම instant එකක්ම ඕනේ නැහැ. Okay, no need to draw the entire thing. This is enough. This is enough. You guys draw this one. Make a and the for your betterment of understanding. This is enough. So representing all the instances, if I apply F equals to MA in this direction, F minus R minus mg sine alpha, which is 1 over 20, is equals to, the weight is given capital M, acceleration is calculated here, but they ask us to calculate only the formulas, only the equations to derive. So I'll just keep it as A itself. Sine alpha is 1 over 20. So I'll keep it as F minus capital R minus mg divided by 20 is equals to MA. This is my second equation. Capital R is a given data, no? They say that the resistance is R Newton. So here A is known. Only F we can calculate F from this. R is known, no? R is given. At this when the velocity is 15 meters per second, which is 54 kilometers per hour, we get, let power be P. Power is given by P equals to F V. P equals to F එක මෙතනින් ගන්න පුළුවන්. I'll just keep it as F. V is 15. This is my third equation. මොකක්ද follow up එක? What's the follow up? From this we can calculate acceleration. මෙතනින් calculate කරන්න පුළුවන් F. මෙතනින් calculate කරන්න පුළුවන් this one, the power. We can calculate the power. හරිනේ? Right. එච්චරයි. So this figure is for your betterment of understanding. Make a අඳින්න අත්‍යවශ්‍ය නැහැ. You can draw this simple figure representing all three instances. Right. So for figure 5 marks. For the conversions 5 marks. Metanta 5 marks. Metanta 5 marks. And then here 5 marks. So totally 25 marks. Okay, all good, understood. I need individual responses. Quickly do a message in chat box. Quickly do a message in chat box. Akif, Ahmad, Alutik Kinik, Aida, Aisha, Hamza, Natasha, Prasiban, Sara, Tuiska, Yusuf. Aisha joined late, right? Overslept. Or some other reason. Right. Do 2020, 2019. Quickly. Your 2020, 2019, do those questions finished off. Okay, no? Right, 2020. A car of mass 1500 kilograms travels on a straight horizontal road against a constant resistance magnitude 500 Newton. Right. Car of mass 1500 kilograms travels on a straight horizontal road against a constant resistance of magnitude 500 Newton. Resistance magnitude is 500 Newton. Find the acceleration of the car. Find the acceleration here. I don't know whether you all are concentrating on when I'm reading and drawing the figure. Right? Go through the recordings and see again. A car of mass 1500 kilogram කියද්දි මම ඉස්සෙල්ලා යන්නේ car එක. Car of mass 1500 kilograms subject to a resistance 500 Newton. උන් කියන දේ එකින් එක ඒ පිළිවෙලට ඇන්දි. So I won't miss anything. Right? They want us to find the acceleration of the car. They want us to find the acceleration of the car when the engine of the car is working at 50 kilowatts. 50 kilowatts. And the car is traveling with a speed of 25 meters per second. 25 meters per second. At this instant, the engine here, they want us to calculate the acceleration. F and the force given by the engine, right? So in this direction, we'll apply F equals to ma, the vector formula, F minus 500, m is 1500, a, we have to calculate it. So let's keep it as it is. I'll create a first equation, and then let's apply P equals to FV formula. P is 50 kilowatts, 50,000. F is the one we have to calculate. V velocity is equals to 25 meters per second. So 25 divided by 25 equals to 1, 50 divided by 25 equals to 2. So F equals to 2000 Newton. Therefore, from 1 we can get 2000 minus 500 equals to 1500. 1500 equals to 1500. A is equals to 1 meters per second, or is m is minus 2. M is minus 2. So acceleration is m is minus 2. So better to write it like this. Therefore, acceleration නැත්තම් මෙතන figure එකේ තියෙන හින්දා no problem. Right. Next what they say, at this instant, at this instant, when the acceleration is 1 meters per second, and when the velocity is 25 meters per second, engine off. When the engine is off, what happens? Now the engine is off, acceleration is not given by the engine. Now what happens? It's subjected to if I'm taking a different acceleration now. It's subjected to a different acceleration now. Why? Engine is off now. Why the different acceleration? Because engine is off. Engine is off. No power, no force, only the resistance. Only the resistance. At some point, what happens? At some point, the velocity becomes 0, no? At some point, the velocity becomes 0. The car, after 50 seconds from the instant the engine was turned off, find the speed of the car after 50 seconds from the engine is turned off. Find the speed of the car. So this one, when the moment where the engine is turned off 25 meters per second, it subject to a different acceleration. It's going to be v meters per second after t time. After t time, right? Patan ganidhi 25 meters per second. The moment, the instant where the engine turned off. under the resistance 500 Newton. No there's a negative acceleration. No? So in this direction, if I apply F equals to ma in this direction, minus 500 Newton, no, the other direction. May පැත්තට plus නම් මේ පැත්තට minus. M is 1500 A. ඒක පුතා, I'm taking it as F, previously ඒ කියලා ගත්ත හින්දා F. F is equals to minus 103 meters per second per second. මොකද්ද මේ ආවේ? Negative acceleration. So actually, what is it? A retardation, no? A deceleration. මෙහා පැත්තට deceleration. So the velocity must be decreasing. So after 50 seconds time, they are asking. Time is given. Time is given. They are asking us to find the speed. Time is given. Speed එක අහන්නේ. Then what's the formula? V equals to U plus AT. And in this direction, we'll apply V equals to U plus AT. V equal one, U is 25 minus A is 103 times 50. හරනේ? Right. So this gives you 75 minus, take a common denominator, 75 minus 50 is equal to 25 over 3 meters per second. 25 over 3 meters per second. Right. That's it. Now finish and 2020 question, do 2020 question. It's 2021 ne? 21 ne, make it 2020. It's 2020, no? It is 2020. Let's do 2019 here. Right. 2019. A car of mass m kilogram and constant power p kilowatts. P kilowatts, huh? Right. Moves downwards along a straight road of inclination alpha to the horizontal. Inclination is alpha. Okay. A car of mass m kilograms, mass is m, so the weight is capital mg, right? So the power is given p kilowatts, right? The constant resistance is R. It goes downwards, means because of this P in this direction, capital F force is given downwards. The constant resistance is in the other direction, R. At a certain instant, the acceleration of the car is A. At a certain instant, at a certain instant, the acceleration of the car is A meters per second per second. Find the velocity of the car at this instant. We'll take the velocity of the car at this instant as V. Right? Same thing as the previous ones. To the horizontal at an alpha angle in the downward direction, let's apply F equals to ma. මොකක්ද වෙන්නේ? F minus R. F minus R. එච්චරද? නෑ පුතා. If I draw a perpendicular line here, this is alpha. Then may direction we have the weight component. What is it? Mg sin alpha. Then F plus mg sin alpha minus R is equals to ma. capital M times acceleration is A kila given. I'll take it as first equation. Now, what's the next idea? දැන් මොකද්ද වෙන්නේ? Now I'm going to apply. නාඩියක් දෙන්න ළමයි මේ කවුද එක්කෙනෙක් ආවා. Right? So now I'm going to apply P equals to FV formula. P equals to FV formula. Power is given PKW. P means the magnitude. Actually, the P kilowatts, no? Kilo means 1000. We substitute in SI units. This power is going to be 1000 P. P kilowatts, no? Kilo is 1000. This equals to capital F. At this instant, the velocity is what? V. May then I use karla. Now I can calculate the acceleration is A kila dila. The acceleration is given, no? And first of all, we'll magnitude, we'll subject this F. No need to take this as 1. F equals to capital MA minus mg sin alpha plus capital R. So if I apply P equals to FV, we get 1000 P is equals to F MA minus mg sin alpha plus R divided by times, not divided by, multiplied by the velocity V. We need to get the velocity. Velocity is equals to 1000. Velocity is equals to 1000 P divided by MA minus mg sin alpha plus capital R. That's the velocity at that instant. Harne. Right? Okay. Next, what they ask. Deduce that the constant speed with which the car can move downwards along the road is this. Constant speed ke liye acceleration is 0 ne bang, acceleration 0 karuwa move 0 wenawane. If the car moves at a constant speed, acceleration is 0. Therefore, the speed is given by, or else constant speed is given by 1000 P divided by, this is 0, and R minus mg sin alpha. මොකක්ද මම කියලා ඩියුස් කරන්න තිබ්බේ? Constant speed නම් acceleration 0 කියලා දැනගන්න ඕන එච්චරයි. ලකුණු 25ක් bonus. මගේ විභාග ගාන. Right. Okay. Do 2018. මගේ නම්බරින් වැරදි නේ පුතා. 1, 2, 3, 4. Hari. 4, 5, 6. Okay, okay. Do 2018 question. Do 2018 question. Do the 2018 question quickly. 18, 17, 16, 15 ಇವರೇ ಹಾಕಲ್ಲದ. Okay, right. Hari, 2018. A car of mass 1200 kilograms moves with an engine shut off down the straight road and of an inclination alpha to the horizontal where sine alpha is equals to 1 over 30. 2018 AL. At an alpha angle, here we have 1200 kilograms, right? It was a, I will take it as sine alpha is equal, sine alpha is given, no, make alpha kila. This angle is alpha, sine alpha is given to us. So we can easily do the simplifications, no? Taking the acceleration due to the gravity, 10 g equals to 10 ms minus 2, find in newtons the resistance to the motion of the car. So car is moving here, engine is shut off, so no this one, no? එයාට කිසිම මේකක් නැහැ. තව මේක මොකුත් නැහැනේ බං මේ ගානේ. Resistance is here, right? Taking the acceleration due to the gravity. Make acceleration due to the gravity as g. This one is g. They want us to take it as ms minus 2. So it's going to be 12,000. Okay. So then this one is going to be 12,000 sine alpha, right? So the acceleration in this direction, let's take it as a. Find in newtons the resistance to the motion of the car, right? Okay. So පොඩි ගානක් පට්ට පොඩි ගානක් මොකද කරන්න තියෙන්නේ? So first of all, let's apply F equals to ma in this direction. F equals to ma in alpha angle in this direction. 1200, 12,000 sine alpha is 103 minus capital R is equals to m 1200 times A. Now you might ask me, so the engine is shut off. If the engine is shut off, is it going to be, isn't it going to be acceleration 0? Acceleration 0 in a puluwanda. The vehicle is moving in this direction. Hari? Vehicle is moving in this direction. Harada? Constant speed they have given at a certain constant speed given, no? I did notice then in a move 0. And there is nothing to do in the calculation. No? Did they give anything else in this one? Or else did I put the question in half in the paper? No, type kara the type kala danne. Let me check with the applied paper, 2018 paper. Yeah, I have put the question in half. Puta question එක භාගයට දාලා තියෙන එක මම බැලුවේ මේ මිලහෝ රහක් නැති question එකක් කොහෙන්ද ආවේ කියලා. Right, question balance part is not typed in the tutor. Questions balance part is not typed. Are type වෙලා නැහැ. So 2018 question only half I have given in the tube, right? Type වෙලා නැහැ. So this one gives you R equals to 4,000 Newton. Resistance is 4,000 Newton. Next what they say, I will read the next part of the question on a liyaganda. Next what they say, resistance to the motion of the car. Methanට වෙනකන් they have allocated marks. අපුතා මේක 1 over 3 නේ 1 over 30 is given, so this is 400 Newton na. This is 400 Newton. Resistance is 400 Newton. It's 1 over 30 දීලා තියෙන්නේ. Right. Right. Now what they say in the question next. When the power of the engine in kilowatts, find the power of the engine in kilowatts when the car ascends in the same road, under the same resistance with an acceleration 1 over 6 meters per second at the instant when the speed is 15 meters per second. Ascends in the same road, what does it mean? Ascends in the same road. Ascends in the same road means උඩට නගිනවා කියන එක. Ascends in the same road. Alpha is given. Okay, with the same resistance. Ascends in the same road, at the same resistance. They are asking us to find the power of the engine. So this one 1200 times 10, 12,000, and ascends in the same road means in this direction we put a force from the engine, but the resistance is going to be in the other direction, but the resistance magnitude is going to be same 400 Newton. Hare, same 400 Newton. The acceleration is given 1 over 6 meters per second at the instant where 15 meters per second speed. 15 meters per second speed. They are asking us to calculate the power, no? Right? Let the force by engine be capital F and power be capital P. Better to write like that. Hare? So එතකොට alpha to the horizontal in this direction. And let's put F equals to MA. Capital F minus 400 minus 12,000 sin alpha. 12,000 sin alpha is 1 over 30. This equals to mass of the vehicle is 1200. Acceleration is given 1 over 6. Acceleration is given 1 over 6. So this is going to be 6 divided by 6 equals to 1. 1200 divided by 6 equals to 2. 30 divided by 30 equals to 1. 120 divided by 30 equals to 4. 400 minus 400 minus 4 minus 800. Take the answer plus 800. F equals to 1000. So the force by the engine. Okay. අපි කියනවා ඒකට write down the technical word. The force tractive by the engine. එහෙම නැත්නම් the tractive force given by the engine. ප්‍රකර්ෂණ බලය සිංහලෙන් කියන්නේ. හරි. The tractive force by the engine. Oh නෑ නිකන් just force by the engine කියලා ගත්තා no problem. Tractive force due to the power given by the engine is 1000 Newton. Hare. So for the vehicle P equals to FV, I have introduced whose P, power as P. So P is equals to F 1000. At that instant, 15, they're asking us to calculate the power in kilowatts. Find the power of the engine in kilowatts. Meaning in watts. So this gives you power is equals to 15,000 watts. So then power is equals to 15 kilowatts. 15 kilowatts. Find the power of the engine in kilowatts when the car ascends in the same road under the same resistance with an acceleration 1 over 6 meters per second at the instant when the speed when its speed is 15 meters per second. Right. That's 18. Now try 2017. ඉවරයක් කළා දැන් 2017. What is it? A truck of mass capital M kilogram is towing a car. One minute. Huh? You guys continue. Okay. 2017 AL. A truck of mass capital M kilogram is towing a car of mass simple m along a straight horizontal road by means of a light inextensible cable which is parallel to the direction of the motion of the truck and the car. So it's a horizontal road. The resistance to the motion of the truck and the car are lambda mu newtons and lambda m newtons and lambda capital M newtons, lambda simple m newtons respectively, where lambda is a positive value. At a certain instant, the power generated by the engine of the truck is P kilowatts and the speed of the truck and the car is V meters per second. V meters per second. Show that the tension of the cable at the instant is this. What is in this is the car, right? Car and the tow truck. This is capital M. Practically think, will you? This one is why the car is towed. Why tow truck is pulling the car? What's the reason? Yako muke car ka kadila. Ena muke engine meta karanne. Right? So the only force that pulls this one in this direction is the tension of the string. So method with the tension, no, same tension is pulling the tow truck also in this direction. But since this one puts a power from the engine, the tractive force may method. So on this, in this direction, to this one in this direction, there's a lambda capital M resistance. For this one to this direction, there's a lambda simple M resistant. Lambda capital M resistant, lambda simple M resistant. At an instant, okay, at a certain instant, the power generated by the truck is P kilowatts. The power generated by the truck is P kilowatts. Right. Now what they say, at this instant, and the speed of the truck is V meters per second. Meya speed deka. Here see, speed of both of them is V meters per second. Right? Practical, no? When we pull this one with the tow truck, the speed of the tow truck is going to be the speed of the car. Otherwise, if the speed of the tow truck and the car's speed is different, in a tow truck, if someone is thinking, sir, speed of the tow truck is 10 and this one is 20, tow truck right? Practically think what happens. Right. They didn't mention anything about the acceleration or a constant speed or anything, no? Right. Now what we will do? Just apply F equals to ma in this direction. We don't know the acceleration and no clue about the acceleration. I'll take the acceleration as a. So what I'm going to do is for the entire system, for the car plus truck system eකට, when we are applying F equals to ma, consider for what system? I'm considering for the entire system. So if I apply F equals to ma in this direction, this tension becomes an internal force, no? Tension becomes internal forces, internal reaction forces. So we can ignore. In this direction, only forces are going to be capital F minus lambda simple M minus lambda capital M. This is equals to, I'm considering for the entire system, total weight is going to be simple M plus capital M. Entire system's weight is capital M plus simple M. Acceleration is the one we have to calculate. Acceleration they wanted us to calculate what puta? Tension. Tension is the one we have to calculate. First of all, we'll calculate the acceleration. Now, for the entire system, if I calculate P equals to Fv in this direction, whatever the direction, it's a scalar quantity. No? So we get power is given P 1000 P. The force the tractive force by the truck. This one is actually put for the truck only. F, they have given the velocity is v. So from this we get F equals to 1000 capital P divided by v. This is 2. This is 2. Then from 1 and 2, we get 1000 P divided by V minus lambda simple M minus lambda capital M is equals to, minus lambda as a common factor, I'll take it as take it outside, is equals to simple M plus capital M A. From this we get 1 over simple M plus capital M times 1000 capital P divided by V minus lambda times M plus capital M is equals to A. We got the acceleration. We got the acceleration. Now what I'm going to do is I'm going to consider car only. If I consider the car and apply F equals to ma in this direction, what are the imbalance forces in this direction? The tension minus lambda M is equals to, what is mass? Mass is simple M, only the car. Acceleration is this entire thing. Acceleration is this entire thing. Yeah. Acceleration is this entire thing. 1 over simple M plus capital M, 1000 P minus lambda M plus M this is what we get. Now simplify, take a common denominator and simplify for the mahitani capilla gihilla expression ek lassanta enawane. Right. So we get capital T is equals to simple M over M plus capital M 1000 capital P divided by V minus lambda simple M plus capital M plus lambda M. Lambda M. Now remove the brackets. Remove the brackets. Here we get tension is equals to 1000 P divided by V times M over M plus capital M plus capital M minus lambda M plus capital M times simple M divided by M plus capital M. Right? It was say plus lambda M. This one and this one cancelling out. We get minus lambda n plus lambda m 0. So we get the tension is equals to 1000 pm m times p divided by capital M plus simple m times simple v. Right. That's it. Simplification එක තමයි පොඩ්ඩක් කල්පනායෙන් කරන්න ඕන. That's a simple one. ඒක පොඩි ගානක්. Okay. Right. දැන් පුතා කරන්න ඕන හරිය කරලා ඉවරයි. Right. You guys have to complete the balance questions. Right. Make a mark. This one's marking scheme you can already find it on the internet. But අවුලක් නැහැ මම මේකට කියලා වෙන marking scheme එක මම ලියලා ඔයාලට දාන්න. Right. So next in our 26 batch එකට mainly I'm saying our pure maths class, we are currently doing integration almost now 50% plug integration, 50% and 45% plug integration done, right? So we have to discuss some of the standard integrals and then techniques of integration and then definite integrals after that practical application with that integration done. Applied maths, we just started relative velocity and we'll be finishing relative velocity by the second week of December. හරි ඊට කලින් සමහර විට ඉවර වෙන්න chance එකක් තියෙනවා. Right. So today's session, before we wind up, drop a message in chat box. All good, understood. I need individual responses. Clear? Doubts part මොනවා හරි තියෙනවද? අම්රට IT exam එකේ admission ගන්න ගියාලු. and ඊට පස්සේ Natasha, she is not well කියලා කිව්වා. So what do you think about this lesson? Lazy the Amaruda. How about this lesson? What do you think about this lesson? Patta lazy the Amaruda. දෙකයි තියෙන්න පුළුවන්. Confident පිට කියපො. මෙලෝ රහක් නැති පාඩමන්නේ. Right. This is just a lesson. 27 උන්ට නම් මන් දන්නේ නැහැ කොහොමද කියලා because their brain is not still properly developed තාම vectors තරම මෙහෙම මුකුත් කරලා නැහැ නේ. And I think in physics class also Newton's laws කරලා දන්නේ I can't remember. I don't know. Okay then. Tomorrow we have the paper class. Then get ready for that. Okay. So හෙට paper 5 එක අපි live class එකේ ලියනවා හරි. So then that's it for the day. Today's session done. So next week, Wednesday, we'll be discussing about frameworks. Frameworks fully venawa next Wednesday. And the last Wednesday, we'll be discussing, what do you call this one? Impulse and collision. Ekath ekka short question paper එකේ ලොකු වැඩ ප්‍රමාණයක් done. So that's it for the day. You all can leave. We'll meet in our next session. Good luck, guys.